Welcome everyone to the official Altera Innovators Day 2025 live stream. Little something I've concocted with the guys here at Altera. Today is their annual Innovators Day. They're going to be doing this every year, and we've got a bunch of high-profile keynotes for you that we will watch along and then discuss afterwards. My name is Ian Cuttress from More Than More, and joining me is my old boss, Ryan Smith.
Yeah, now working for Ian, essentially for this one, but it's a good partnership either way.
I'm not sure if you know a little bit about our history. I spent 12 years at Anantech. You spent 15, 17? 19. Jeez. And we're the same age, pretty much.
Yeah. Hey, you just had a birthday.
Welcome to 40. But yeah, so we've decided to organize this live stream together with Altera. Because they've been in the news lately, and it's a big moment for the FPGA business.
Oh, yeah, it is. Altera is free of Intel, which may sound a little harsh, but that's all about their strategy now that they're no longer directly under Intel's thumb. They're going to be a pure play FPGA foundry, and that's what they're going to push hard as one of their major advantages.
I mean, we were, to a certain extent, covering Altera back when it was pre-Intel Altera, right? About 2015, Altera got acquired by Intel for $15.6 billion.
Sounds right.
About that much. And the idea was that Intel wanted a FPGA part to their compute portfolio, which is fair enough. We've seen AMD do something similar very recently. But that became the Programmable Solutions Group. And we spent many a meeting with them, understanding the way their new portfolio was going to go. One of the targets for that acquisition was bring everything on an Intel process. Get economies of scale, economies of building silicon on your own node increases margins. FPGA can be a very high margin business when done right.
Emphasis on the when done right.
Yeah. It's when you look at the FPGA space, there's kind of three markets, right? There's the edge, which is up to about 100,000 logic gates. There's the mid-range, which is somewhere between 100,000 and 500,000. Some people say maybe 1 million.
It's more than 1 million now.
And the high end, add in HBM, add in 3D stacking,
add in RF elements.
Yeah, all sorts of different levels of programmability. Now, for those of you new to this industry, you will have heard the phrase, I hope, CPU, GPU. Normally, if we keep going along that line, we have FPGA, so field programmable gate array, and then ASIC. Most of the time, most people spend their life in the CPU, GPU era. If you want to go design a chip, though, you need an FPGA. The whole point about an FPGA is that you can design circuits on circuits, which makes you wonder how they designed the first circuits in the first place.
By hand on blueprints paper.
Yeah, literally drawing the transistors.
Yep. Which is easy enough when you only have a dozen of them, 100 of them, 1,000 of them.
Have you been keeping track of Sam Zeloof recently?
No, I can't say that I have.
So Sam Zeloof is, when he was 16, he was building transistors using lithography in his garage.
Nice.
He managed to, through eBay and other means, get access to some very basic deposition and lithography and etch and cleaning tools.
Oh, very
such
cool.
that he was building chips with 1,000 transistors on his own.
Yeah.
Not in a clean room.
Yeah.
I mean, that's not to say that they necessarily worked or formed a circuit, but he was doing it.
Yes.
He was doing the chemistry behind it. He now has a startup called Atomic Semi, which is trying to do lab on a chip is wrong. It's chip in a lab. It's the other way around. It's how do you build a chip quickly and efficiently, but one at a time, not wafers at a time.
You want to do small scale runs instead of big scale.
But if you want to do more than that, that's where the FPGA comes in, right? Yeah. I've seen racks and racks and racks at companies like Intel, like AMD, where they're just simulating their next AI chip design
Oh, sure. I mean, we'll take NVIDIA, for example. Their whole big thing is that they get it right the first time. They want to ship A0 silicon. They will take their time to do all the simulations, and only then will they finally tape out a mask and send in production.
Yeah, that's obviously at the high-end scale. The reason why you might need a small FPGA is for a control subsystem in your John Deere tractor. But that tractor is going to be in the market for 15 years. So how do you have a chip that does what you need it to do and also has the increased security over that time? Enabling something like an FPGA means that you can update the security, update the feature set over time, or replace it like for like, because FPGAs stay in the ecosystem for 10, 15 years.
Yeah, even though obviously the FPGA won't get more performant over its lifetime, as long as you can at least update the algorithms it uses and other bits of its operation, you can still at least keep it contemporary with current standards and requirements.
Or if you're designing a full new PCB for the same device, you can ensure that you're emulating what it used to have properly. I mean, FPGAs exist a lot in retro gaming consoles.
And what is it, the analog NT?
Something like that. It's the ability to take NES, SNES, Mega Drive, Genesis, even now Dreamcast and PlayStation 1 fully emulated in an FPGA, right?
Correct.
It's insane how powerful these things have gotten, and what Altera is looking to do, as part of this new spin out from Intel, is approach AI. The AI word. It's AI is like a part of the business, right? They still have a large legacy business.
Yes.
But I've actually worked with a couple of the AI hardware companies, and they're shipping their first product in FPGA.
Okay.
So it's so expensive to get leading edge silicon.
That's an understatement. Yeah.
Yeah, it makes sense to do the leading edge prototype or the first prototype that you actually commercialize with something like an Agilex 5 FPGA.
Yeah. And the interesting thing about that, the Agilex, speaking of leading edge here, they're actually not leading edge. So all the Agilex stuff is currently made on Intel's 7 nanometer family products. So Intel 7 and even some products are still 10 nanometer superfin.
One thing to say here is because these products exist, for a long time in the ecosystem, you look at the FPGA companies and their revenue, for the ones that publish their revenue, 80-90% is still on products released 5 years ago.
Oh, yeah.
Right? Anytime they introduce a new product, it takes time to ramp. We often say the machine learning industry right now is actually pretty fast. If we look at standard CPUs, GPUs, they can be on an 18, 24-month cadence. Automotive is on like a 5 to 7 year with an FPGA plays in that sort of 5 to 7 year, or historically has.
Yeah, I remember seeing something like that in your interview with Altera's CEO the other day.
Yeah. So if you didn't catch it, yesterday I posted an interview with Altera's new CEO, Raghib Hussain. He's actually going to be leading the main keynote today. I haven't actually gone through the procedure for today. So what we wanted to do here is, this is essentially the setup phase, where we talk about how we've interacted with Altera in the past, before the keynote, which is going to run at 9 p.m. Pacific, so in about 20 minutes.
9 a.m. Pacific.
9 a.m.
We're not that far ahead yet.
Can you tell I've been traveling too much?
Yes, you have.
3 states in 3 days. It's fun. So we're going to go over to them, and you're going to be able to watch and listen to the full keynote here on the channel. That's going to run for about an hour and 15. And when those 2 keynotes are over, we're going to come back into the studio here. We're going to discuss what's been announced and hopefully have some guests. I actually bumped into the main Altera distributor in the lobby. So he might be coming in for 5 minutes. That's I think his title was President of Distribution of America for Arrow.
Okay. So that's definitely people you want to be in talks with.
Yeah, in the FPGA space, the companies that I've been tracking semi-regularly, you look at the product distribution, 80 to 90% is sold through distributors like Arrow. Literally just websites where you go and buy 100 or 1,000 of the things and they send you a reel or they send you, 100 PCIe cards, that sort of thing.
Yeah.
And
just a whole tray of chips, multiple trays even.
yeah, so even if you might think, oh, well, hang on, doesn't NVIDIA do this and Intel do this and AMD do this, and put them on the boards for their reference designs or what have you, or maybe Supermicro. Supermicro may buy direct. They're like 10-20% of the volume that's direct, or the revenue that's direct, but everything else goes through distributors. And so having the strong distribution network, and I know this has actually been a criticism that's been laid at Altera before, under the Intel days. This is why I kind of want to talk to the Arrow guy about what's changing in that model. I remember being approached at a conference of people saying, we'd love to get hold of, the Agilex FPGA, the one that we want, the one that we need to test it. We need to, validate and verify it for our use case, but we can't get hold of it. How do we do that? And you'd think Amazon buy it now. But also on that front, I know we spoke a little bit about before, the concept of FPGA developer kits.
That's a huge one. How are you supposed to develop anything for an FPGA if you can't get the rest of the kit needed to become a developer?
And this is some of the weird dichotomy, right, of the FPGA business. They have 10,000 customers, but all of them, their minimum order quantity is 10,000. So if you're somebody who wants 1 or 10, you're not really in their purview. But in order to even know that you want 10,000, you might need to buy 1 or 10.
At some point, you got to test it and make sure it's actually what you need before you buy the other 9,900.
Yeah, which means the barrier to entry for FPGA is quite high, not only in terms of acquisition, but also knowledge. I mean, people who design FPGAs are either wizards or eccentric or...
it is a very specific knowledge set, an incredibly important set of knowledge, but yes, quite different from any other aspect of chip creation.
Yeah, because usually you visualize circuits as an idealized binary clock tick, and everything's fine. And then actually it's very slightly analog, but then maybe you need to design analog circuits in an FPGA, and then that gets funky. I did a video recently about how somebody was trying to emulate 3D logic in a monolithic piece of silicon on a 2D FPGA. But the concept was for 3D FPGAs, and the change in interconnect between your circuits as you go from a bottom layer to a top layer, rather than having to traverse all the way across the chip. So it's not only for let's build the future chip, it's also for let's pathfind. Let's decide what the next 5, 7, 10 years have in chip design. It's I'm pretty sure I've said this before on the channel. Whenever I speak to Jim Keller, he says there are only 19 people in the world he trusts to write vectorized code because it's so difficult.
Yeah, you have mentioned that before, and 19 people might be trusting a few too many people.
Yes, yeah, but then we get to the land of FPGA circuit design, and if you're right into the Verilog, the VHDL of it all, I'd argue that's even more complex at times.
Absolutely.
This is why you have companies like Synopsys and Cadence who build the IPs, and FPGAs have this concept of soft IP and hard IP. So hard IP is the stuff that's actually built into the silicon. So this might be, hey, you've got an FPGA on a PCIe card. The PCIe controller is there. But a soft IP is just designed in the circuits. So you could have a hardened PCIe 5, but then you have a PCIe 6 in the soft because you're trying to design it. And then you have another connector on the top end of the card. That's your PCIe 6. I actually saw some of those at DAC this year. Yeah. And even, so PCIe 6 is pretty much done, but PCIe 7. Yeah. And
I think the 8 announcement is coming up.
Yeah, I think they're on version 0.3 or 0.5 or something.
Sounds about right.
Yeah. So, testing IP before you actually go design it in hardened silicon, which is an even worse problem to have, which is all actually fundamentally being accelerated by machine learning. And it's interesting when I've spoken to FPGA companies, they design machine learning stacks for their hardware to be used, but they don't necessarily use machine learning in designing their own chips yet. And that's because an FPGA is a very regular design. You've got your circuits, your lookup tables, and your fabric, and then it's just copy paste across, almost like a GPU.
A little bit.
Ryan knows a lot about GPUs. He spent so long reviewing GPUs.
So very long.
Do you miss it?
I miss a lot of things. I don't miss the image quality testing these days. Having to do ABC testing between different versions of DLSS and AMD's equivalent. It's like going to the optometrist and they're trying to figure out which lens is the right one. You go through a billion of them, then you go back through them again.
Well, yeah, because we had that image accuracy issue beforehand. I remember the standardized tests that people wrote to do it, just to make sure you had color accuracy.
Correct.
Which is crazy to think about.
And then for a while everything was standardized, and essentially everyone had identical image quality except for maybe some weird FP16 edge cases, and then DLSS came out and other forms of super resolution, and it changed the game both for performance and for image quality. But it also means everyone has differing image quality again, so now we're back to subjectively trying to figure out who does it better, because there is no canonically correct answer.
So I spent last week with Qualcomm. I spent the last couple of days with Intel, all talking about brand new stuff I can't talk about. But yeah.
Oh, come on, you can tell me. Just you, me, and a camera with a bunch of people on the other end.
It's DLSS and gaming were mentioned in both instances.
Oh yeah,
it's important workloads, right? Normally when we say CPU, GPU, FPGA, ASIC, right? The CPU runs everything and is a host. That's its goal. The GPU runs a vector of serial programs.
Correct.
Which is not a true vector processor, as people like to remind me. That's a DSP, digital signal processor.
It's a bunch of SIMDs, close enough.
It's FPGAs in this weird mix where if you get it right, it can be fast on the CPU. It's not as fast as a GPU because of compute density is a big thing there. But it's also the power efficiency is somewhere between the two. But because the barrier to entry is so high, we typically put it, beyond GPU in terms of use and specificity, I think.
Yeah, it's a good way of putting it.
Even though an FPGA can pretty much do everything.
Yes.
If you put your mind to it. I remember it was a few years ago, and one of the interesting metrics is how much can you actually simulate on an FPGA at once? And it's like, this ARM core, or this ARM core, or this E core, and the idea is that when you get to 100 billion transistors or whatever we're approaching too soon, how many racks and racks of FPGAs do you need to actually simulate that, either cycle accurate or time accurate sort of thing? It's a very complex industry that doesn't get enough attention, and I think again that's an understanding issue of just how complex these devices are.
Yeah, it's not a consumer-facing business for obvious reasons. So it's all in the background. It's engineers toiling away in random Silicon Valley offices.
Yeah. It's so in the past when we've covered Altera, they sort of pre-acquisition was the Stratix line of hardware, and that's where we saw some of the first HBM silicon. Some of the first, some of the first EMIB silicon was actually part of when they were under Intel. The first ever, die-to-die interconnect with in-package silicon bridges was done on the Stratix 10 MGM, XGM, something.
Yeah, there are M's and some X's in there.
I remember writing that that was the first time we saw logic connected to logic with EMIB.
Okay.
Because my issue there was always, if you have two logic chips next together, you're going to have thermal cycles up and down, and then potential warpage as metals shrink and contract. And at that time, the embedded bridge had only been done logic to memory.
Correct.
So it was an FPGA where we saw logic to logic as the first announcement. So that was pretty cool. And then I want to say like 6 years ago, Altera announced the Agilex family, which is their Intel 10, Intel 7 nanometer product line, following very much the Intel naming scheme. Agilex 3, Agilex 5, Agilex 7, Agilex 9, just like Core i3, Core i5, Core i7. Oh, well, the i's now dropped in the consumer line. So Core 3, Core 5, Core 7, Core 9, to provide that range. Though at the time, the release cadence was incredibly slow. Do you remember?
Yeah, on the order of 3 to 5 years, something like that.
Yeah. Excuse me, my phone's going off, and I don't know why. It turns out I'm getting loads of messages, even though I put my phone on silent.
It just made you popular.
Yeah, there we go. It's the idea being that Agilex 3 is for the edge, Agilex 5 is more sort of mainstream, and then Agilex 7 if you want compute, and Agilex 9 if you want extreme.
Yeah,
everything.
Exotic extreme technologies, HBM, RF, etc.
Yeah, well, so Agilex 5 also has HBM options, just because that market needs them, and the FPGA market is very much you might see it as the ultimate flexibility, but because the chips actually cost a lot, there's that sort of refinement in price and feature set that needs to happen in the FPGA business. Unlike most other businesses, is very vertical driven. Yeah. So you have automation, simulation, emulation, telecommunications. Now you have robotics. It's a big thing. FPGAs are used in automotive and robotics for sensor fusion, the ability to take in data from multiple devices at once in multiple data formats, and to create the circuit that enables that to run fast. Because trying to stitch together six cameras into a 3D space is actually really mathematically complex.
Yeah, it takes a little bit of processing power.
So I remember when those 3D cameras, the 360 cameras first came out, and they were big and chunky and required so many cameras, and then at the heart was the FPGA, and they eventually miniaturized it, made it into ASIC-like form factor, and now you can get them that thin.
Yeah, that sounds about right.
Yeah. And they went out of fashion. It was a little bit of a fad for a while. We're also seeing one big place where I'm seeing FPGAs crop up a lot is in security. The US has NIST, the National Security.
Yeah, National Institute for Science and Technology, I think it is.
Yeah, so they've been at the heart of all the encryption standards in the US. China has something very similar. And the idea is, well, which cryptographic standards do you want to support? Or perhaps there's a new one you need to support, and rather than spin up a whole new chip, let's just have this little bit of an ASIC that we can reconfigure to do these specific cryptography algorithms. The most recent ones are post-quantum crypto.
That's a huge one right now.
Yeah, so NIST has validated 3 standards as being post-quantum crypto safe. A 4th one is in the works. And I'm not saying that there was a rush to get it into silicon first. I believe that was succeeded by a company called PQ Shield.
Okay.
In the UK, they did it on a GloFo 40 process. But anyone who has any sort of FPGA has been able to do it as soft IP for a while. It's a funny thing. The first time I think I saw it in action was for IBM tape drives.
Really?
Yeah.
Huh. Interesting place to put it.
I was touring their German facilities at the time, and that's where they do a lot of their tape drive development. And this guy was showing me, their next generation tape drive. And obviously, tape drive is a very specific niche now. But he was saying, oh yeah, no, we use this FPGA, and this is where we do our post-quantum crypto, and our customers have had it for 2 years.
Okay.
So long-term data storage, that whole ecosystem is worried about if somebody takes my data today, they might encrypt it in 10 years.
Yeah.
The question is, does that data still have value in 10 years?
Some of it, absolutely.
If it happens to be, bank account data, then sure. Or login data to, Gmail or what have you. But even with that worry, the rush to post-quantum crypto hasn't been as big as I thought it would be. I mean, Intel said that they're committed to enabling it in 2030.
Yeah,
a while ago.
Everyone will get there. I think a little bit of the lack of a rush is just because nobody has built a quantum computer yet that can actually crack all this. But the moment somebody does, let's be honest here, there's going to be a massive rush in the industry to quantum crypto harden everything.
Or a massive rush from a government to stop it getting live.
That too. Either way, the pace will pick up then. Until then, everyone is moving at a slightly more leisurely pace. But still, talking to Rambus about post-quantum crypto 5 years ago because they're putting out the IP for it. So it's a process on its way.
But all the development there and all the how do we enable it today is all FPGA.
Yeah.
I mean, that's what enables it. We're going to be coming up to the live stream here in about 5 minutes or so. We'll see if they're running to time. The countdown on the thing is just saying 4 minutes or so. I've actually, cause I know that they've shared what they're announcing with us. I purposely haven't read it yet.
Okay.
So
interesting. All right. Yeah, I read it ahead of this just to make sure I was well versed.
Yeah, so a lot of what Raghib, the new CEO, and Ilya, one of the engineers, is going to be talking about is going to be the new era of Altera. I mean, just before we start here, what did you think when you heard the news about Altera spinning back out?
Well, first of it, I looked at it from a financial perspective. Intel eventually sold off 51% of it to Silver Lake for a valuation of about half of what they paid for the company. So Intel squandered about half the value of Altera, but they lost that value because they weren't doing much with it. Altera was this itty little bit of Intel, $100 billion company. Altera's 2024 revenue was only about $1.5 billion.
Only? I'd love a revenue of
it is. Well, that's a lot of money unless you're Intel and you're making 50, 60 some odd billion revenue in a year. So it makes it hard for a company like Altera to stick out, to get attention, get resources, et cetera. So the fact they're spinning out, on the one hand, it means Intel has basically given up on their combined Xeon plus FPGA play, but they weren't really making any real headway there anyhow. So it's better for Altera to be out on its own. So I'm looking forward to seeing what they can do.
It's when I spoke with Raghib during the interview, it was all about flexibility. All about being agile. It's being able to control your own destiny sounds a bit weird, but when you don't, if you have 5 layers of management, it's easier to get stuff done than having 7 layers of management,
yes.
Right? And when always you get consumed as part of a big company, we know this because from an Antec being acquired back in the day, just the extra layers of management that need to go on to get anything done. But I'm still working with a good chunk of the same people I did pre-acquisition. Altera workers, Altera employees, a good chunk of them stay here 20, 30, 40 years.
Yeah, we're in Altera's original building right now. They had before they were acquired by Intel. So they've basically gone right back to where they left.
So again, a brief recap of what today is. Today is Altera's Innovators Day. This is their developer conference that they plan to run annually. It's a chance for the company, now that it has split from Intel, to reintroduce to the entire community who Altera is, what Altera does, and why Altera matters. This event is particularly important because we have a new CEO who's going to come on stage and define his vision. Again, if you're interested in learning more, I have an interview with him that we've actually posted on the channel yesterday. It's very well worth a watch. You can also read it over at more-more.com for the transcription there. And what I'm hoping to see here is, again, that renewed commitment to, instead of going after the 100 customers, let's go after the 10,000 customers. Let's reintroduce competitiveness into the FPGA space. Let's be let's be able to decide what process node we want to use, what target market we want to go after, what customers we need to satisfy, where the software needs to go. Because I saw that there was a bunch of comments on the interview about software and the evolution of where that goes. And it gives an opportunity. I think this is actually round about the right time, just because machine learning is so important, to say, hey, let's redefine our product stack, our cadence, our update cycle, and actually give the customers what they need rather than what we promised them 6 years ago.
Yeah, the new CEO, what's moved to what, a 12 to 15 month cadence for products? Mm-hmm. Yeah, for FPGAs, that's unheard of.
Yeah, we're getting the go ahead to so during this keynote. We'll be off screen. We'll let you watch it uninterrupted, and then we'll come back when it's ready to go. So we'll see you in a bit.
Where we are Altera again and uniquely focused on making the best FPGAs in the business. So I know Tom went into the vault and grabbed a couple of fun things to share from Altera 1.0.
Okay, this is audience participation, so shout out the answer verbally or raise your hand. Can anyone tell me what this is? Floppy with what? Max, well, not Max plus 2, Max plus. This is 1980s. All right, so that's prop number 1. Good job.
That's actually cloud version 0.1.
Yeah.
And it's still what you see in the Office products where you push save. You still see that little picture?
That's a disk. Anyone know what this is? Tape. What's the tape? Of what? Nope. What do we sell here? We sell chips, right? Silicon? Remember the term tape out? Where does that come from? Right here. This is a tape out. 1988. One of our old classic devices here, tape out. This is the actual tape out.
So that's a complete device database on that tape, and that's where we get the word tape out from, is they'd actually send that to the fab. Tape out the door. Yeah. Oh, okay. I didn't know we were going to do tricks. Anybody remember what this is? What was Excalibur from, Joel?
That's a long time ago. It's amazing to see that we've got that that still. Now all our devices have ARM hard subsystems, and Neos is based on the RISC-V architecture.
Oh yeah, Excalibur came first, but progression. Lots of different processors, soft, hard, leading up to some of the current ARM stuff, which you guys are going to see in the Agilex 5 devices.
Okay, I'm Jeff. I'll be in 1117 helping out with the embedded demos. We'll leave Tom to give you guys a couple more important notes like evacuation procedures, so pay good attention.
Yep, thanks guys.
And I'm Joel Seeley. I'll be in 3171.
Okay, great. Thanks. So we do have just a very, in case of emergency, fire, probably more like an earthquake, just head out to the parking lots back where the breakfast tent was. Any of those parking lots will be fine. Just head out through any of the doors, that'll be fine. The good news is, if you can't see right over here, the fire station is right next to our building, so the response time is pretty darn quick. All right, the agenda. I'm not going to bore you with the agenda. The one thing that I just wanted to highlight, a couple key things, is there's a session here people not aware of. So we've got the 3 sessions, the breakout for whether it's design tools, AI, or embedded SoC. During the tutorial session after lunch, we also have an optional security session. So we have both a session and a panel. We didn't advertise that or promote that very well, but if you're not going to go take a tutorial, come back here to the auditorium. I think it's going to be in the auditorium. That's the plan. And we have a whole session going into details on security. In fact, this is the panel that we've got lined up. So a combination of Altera experts. We got some customers and some partners. So it's going to be a very detailed look, and this open Q&A as part of the panel as well. So I just wanted to make you guys be aware of that. The other thing, if I know all of you have registered, you're here, but not all of you told us what tutorial you're going to sign up. So somehow between now and lunch or breaks, let's get back to the registration area. Tell us what tutorial, because we've set the room sizes based on the tutorials. And we have some ideas based on what you kind of registered online, but we don't know now that you're here where you guys are going to go. So please, if you can take care of that, tutorials only. The sessions before lunch, just go to the rooms. It's just the tutorials, because those are hands-on. We need to have laptops. We need to have seats. We have monitors for everyone. So please, if you could help on that, that would be great. Okay, the other thing, too, is after all the sessions, you have a QR code that's going to come up. Get your phones out. We're going to ask you to fill out a short survey, set of questions. And then every time you fill out a survey, we'll put your name in for a raffle prize that we're going to announce during the networking session. The more times you fill out the survey, the more chances that you win. Customers only. Sorry partners. Sorry distribution partners and other folks. Okay? And then you're going to need on your badge, there's a number. So when you get into the survey, check your badge. Use that little number that's at the bottom. That's how we'll uniquely identify you and get your name into that raffle prize at the end. All right, in case the rooms, right, if it's confusing, we've got the 3 breakout rooms. So next generation design tools. Did anyone see the press releases this morning? Nope. We take a look at it in breaks, not during Raghib's keynote. We announced a bunch of new things. One of the key things is a next generation system integrator tool called Visual Designer Studio. So design entry tools, obviously for the embedded SoC folks, and then AI. Those are the locations. Then after that, you guys go to lunch. You guys come back, go directly to the tutorials. If you guys are confused, see one of us, and we'll kind of direct you to where you're going. Once your tutorials are done, then you head back over to that Customer Experience Center. We'll have the live demos, meet the experts, food, alcohol, things like that. So without any further ado, last thing. In the Customer Experience Center for this afternoon's networking session, in the middle, there will be a bunch of experts in these following areas. So if you don't get a chance to talk to the folks during their session, we didn't have enough time for Q&A, they will be there. So hobnob, meet them, ask the questions that you weren't able to ask during the sessions, okay? With that, let's roll.
Innovation doesn't begin with answers. It begins with curiosity, with those who look at challenges and ask, what if there was a better way? That same question drove us years ago. What if a programmable chip could adapt to endless possibilities? Powering breakthroughs here, and even here. Since then, we've partnered with pioneers across every field, from cloud, communications, automotive, edge, and beyond, transforming possibility into reality. Together, we push the boundaries of what technology can do. Together, we unlock opportunities that impact every person, everywhere. This is why we create. For the innovators. For those who reimagine the future and bring it to life. We are Altera, fueling ideas, powering progress, accelerating innovation. Ladies and gentlemen, please welcome Altera CEO Raghib Hussain.
Good morning, everyone. It is my pleasure to be with all of you today, so thank you for being here today. This is our first Innovators Day as an independent company, and my first opportunity to meet all of you. You may know me, my background is engineering, and I'm an engineer at heart. I love to, having brainstorm with developers and customers, trying to solve complex problems and create great solutions for the world around us. This is how I build businesses in Cavium and Marvel. And this is how we are planning to lead this next new chapter for Altera. It's a new era for Altera. Altera is the world's largest pure-play FPGA company today. Independence allows us to use the full potential and to focus on bringing the programmable solution for our customers. I want to thank all of you to stay committed with us through the decades of innovation, and we are thrilled to have you to be part of this journey as we move forward. So what's new? Being independent allows us to focus our investment on just one thing, rapidly bringing to market highly innovative programmable solution with ease of use that you can leverage to accelerate your innovation. Altera is now a stronger, nimbler company with an unwavering commitment to excellence and putting its customers' business needs first. We are building a culture of extreme ownership, clarity, and accountability. This is new Altera way: agile, focused, and customer-obsessed. With the operational independence, Altera will operate with greater speed and agility to deliver faster innovation to achieve the promise of physical AI, deliver broad portfolio for advanced FPGA solutions, and offer increased support for its customers and partners worldwide with flexibility of supply resiliency. What excites me most is full control over our destiny, allowing us to solve customer real problems with innovation. Today, the industry is going through a rapid transformation, primarily driven by the need to intelligently process and monetize the massive amount of data being created. From edge to data center, businesses are deploying intelligence with real-time, low latency, and secure processing. This is an ideal environment for FPGA due to the fact that FPGA provides the flexibility, the latency, and the reprogrammability. Over a 5-year horizon, we see a meaningful growth across many segments for FPGA deployment. It is going to drive over 10% CAGR with a projection to reach $13 billion by 2030 from estimated about $7 billion in 2025. This is driven by not only the traditional demand of the use cases of FPGA, the workloads which are very broad, but it also is accelerated by the demand for more AI to be incorporated in edge applications. Demand also coming from the fact that the cost of development of ASIC in the latest process node has become prohibitive for many of the applications where ASIC used to be the right solution before. So those applications still need to deliver the latency, the security, the overall bandwidth, and this is where it is additional market growth for the FPGA application. We see a cumulative of over $55 billion market opportunity between now and 2030. And I'm confident with focus and execution, Altera can grow much faster than the market growth. So FPGAs are not a niche. They are fundamental silicon technology with extraordinary broad application. And of course, all of you know this obviously because you are the developers who use FPGAs. FPGAs are the technology which was invented over 40 years ago. But even today, they are not just relevant, but they are essential technology for the modern compute. No other compute platform spans this breadth of application. FPGAs provides the best solution of hardware-based, deterministic low latency, security, time to market, and the flexibility to adapt changes after the actual deployment in the field. We are embracing a developers first mindset in new Altera. Our developers community, including all of you, are creating leading edge solutions using FPGAs. Whether you are developing for IoT, for edge AI, whether you are a data scientist trying to solve a complex problem for a data center application, or whether you are implementing a complex communication solution, you are in charge of our collective future. As an independent company focused 100% on FPGA, Altera is committed to serve the broad market alongside our ecosystem partner with hardware and software performance and features that allow users to innovate from the edge to the data center. While the foundation of an FPGA is silicon, the developer's experience starts with the software and tools. This is why we pay extreme attention to software and tools. With Quartus Prime, Altera is providing the most productivity-centric developer experience. Quartus offers an extreme portfolio of tools that accelerate the development of system-level and embedded designs. These tools help generate IP or RTL to instantiate in your design and seamlessly allow rapid compilation. In addition, our soft IP solution help accelerate your overall design and productivity. Software and IP tools are built to help simplify the FPGA development process and enable you to get to the market quickly. Customer experience has been top of our mind. We listen to your feedback. 3 years ago, we started an initiative to set out to improve the usability of our software tools, an initiative which is called Silverado Trail. We looked at 5 vectors of our software suite. Getting started, how to install, what documentation available, how easily can we access the help, design entry, making it easier to build designs and connect IP, simulation, compile time, and design migration. And today, I'm happy to share that we are leading in 4 out of 5 categories. But we are not done yet. Our focus is to deliver a best-in-class FPGA user experience through software, IP, and solutions that maximize customer productivity and performance. To provide advanced modern software and hardware co-design methodologies to drive efficiency, quality, and total product optimization in overall product engineering. And to cultivate a robust FPGA design ecosystem and innovate at a faster pace with industry trends to expand market reach and create shared success with our partners. Today, I'm also delighted to announce Visual Design Studio, a tool that takes developer experience to the next level. This is Altera's 4th generation system integration tool. Visual Design Studio accelerates IP integration by automating the process of connecting IP blocks in the design flow. The tool automatically suggests IP routing based on users' design requirements and applies valid IP connections to ensure proper functionality. Engineers get access to a user-friendly drag-and-drop block view that allows them to visually place IP blocks and RTL code in the design directly. And it quickly allows them to trace data paths across the FPGA overall design. It greatly enhances time to get started on an FPGA from days to hours when compared to designing with the tools which support RTL only. We have been working closely with early adopters to use Visual Design Studio and get real-time feedback, because this is how we get the real understanding of the use case, and this is how we get a chance to improve our overall tool. One of those developers is Adam Taylor, who I would like to welcome to the stage now and talk more about his experience with this tool. Adam, welcome.
Thank you very much.
Okay. So Adam, tell us about your experience with FPGAs.
Okay, so I've been developing FPGAs for about 25 years now, and we've developed applications for FPGAs across most of the world, really, from like going to the sea to commercial transportation to even in orbit. And like a lot of engineers, I've climbed the management pole. You know, I started out as an FPGA engineer, climbed up to being executive in a company, and then I decided actually I liked being an FPGA engineer a little bit better. So these days I run my own engineering company out of the UK, but we have some staff in the US as well. And it's been a great journey so far for 25 years to see the FPGAs evolve.
Yeah, Adam, we share the fact that we both climbed to the management side, but trust me, I still do hands-on thing, and I'm pretty sure you also do this.
Oh yeah, you never stop.
Yeah. So what challenges you face working on FPGA projects, particularly talk a little bit about design entry?
So one of the things that I always find, and I've talked about this quite a lot actually over the years, is how we architect and capture and design our tools. It's something very close to my heart. I'm a really big believer in the systems engineering approach and the model-based systems engineering approach as well. And I also happen to be a very visual person as well, so I prefer to see visual elements and blocks to help me understand designs. So that's one of the things that I think is we find as a challenge really, is how we go about architecting our designs and our solutions and getting them into production quickly.
So talking about visual, you had first-hand experience with Visual Design Studio. Tell us more about it.
Okay, so I'm very impressed with what I've seen so far. We had access to one of the early versions of this, and it enabled me to design the system, and we'll be talking about that later on, around an image processing based solution. Speaking as an engineer, it aligns with my interests and my views. Speaking as a business owner as well, it actually helps my team be a little bit more productive as well, which is always good.
Thank you, Adam.
No problem. Thank you.
So be sure to catch Adam's session at 10:25, where he'll be demonstrating Visual Design Studio. So Visual Design Studio is available in our latest Quartus Prime 25.3 release, which is available for download today. Our Quartus Prime 25.3, Altera delivers the scalability needed to the next generation FPGA design across industries. Quartus is engineered for developer success by empowering teams with an intuitive, high-performance design environment. Deliver unmatched design outcomes, driving productivity and quality to accelerate innovation and time to market. Integrating design 20x faster with Visual Design Studio and 27% faster compilation. And we also have FPGA AI suite, which makes it easy for you to add AI, just like any other IP. So designing for AI is nothing special or odd here. It's a part of overall integrated design environment. These tools are built to support best-in-class FPGA silicon architecture. Agilex is Altera's flagship programmable solution and demonstrate how we are delivering industry-leading products via our chiplet strategy. Agilex features the industry's best architecture, delivering leadership performance per watt with our second-generation HyperFlex architecture. In addition, it has enhanced AI support and advanced security features to ensure confidentiality and integrity of the device. Our commitment to helping FPGA developers to leverage the power of AI in security is reflected in our Agilex FPGA portfolio. We are the only FPGA vendor to infuse AI tensor blocks in the FPGA fabric of our overall Agilex design families. These bring dedicated hardware-optimized acceleration for AI and ML while retaining the flexibility of an FPGA. In addition, Secure Device Manager includes PQC and secure boot capabilities to help you future-proof your design against the post-quantum threat vectors. Today, I'm extremely happy to share all members of Agilex family are shipping in production. Agilex is built for broad market. From our high-end Agilex 9 and 7 to our mid-range Agilex 5 to our cost-optimized Agilex 3. Agilex 7 and 9, along with second-generation HyperFlex architecture, gives users 2x performance per watt and 1 speed grade advantage. With today's news, we are expanding Agilex 5 family to include higher density devices with up to 2.5x the logic, memory, DSP, and AI compute capacity. In addition, Agilex 5 offers increased DDR5 speeds up to 5600 megatransaction per second. This is ideal for edge application where high bandwidths are needed. For example, inference involving video traffic, 4K and 8K videos processing, or 5G, 6G wireless infrastructure. We are also now shipping Agilex 3 in production devices with ARM HPS multi-core subsystem. Altera's full portfolio of programmable solutions are built to address all markets and applications. Our prior generation products continue to deliver excellent value for our customers. And now Agilex is the portfolio to deliver your next generation innovation. Agilex 9 is designed for use in high bandwidth mixed signal applications that have size, weight, and power constraint. It is only FPGA to integrate high bit rate analog converters within the FPGA fabric and are ideal for radar, aerospace, and defense applications. Agilex 7 has industry's highest performance fabric and transceivers. This is best suited for high bandwidth applications like data center, communication, test, and video processing application. Agilex 5 is balanced for power, performance, area, and price. A best-in-class mid-range FPGA packed with tremendous feature set, including fabric infused with AI tensor blocks, latest generation of memory support, for example, LP5 and DDR5, and quad-core ARM processor for edge AI wireless networks application, video and vision application, medical devices, robotics, and many more. Agilex 3 are power and cost optimized devices and are foundational technology for numerous applications, including industrial, factory automation, board management, drones, and many, many applications. Let's take a look at one of the examples for Agilex 5 device application, which is rapidly evolving application in robotics. At the core of robotics is a simple cycle: sense, plan, act. This loop must be fast, reliable, adaptive for robots to operate safely in a real-world environment. whether it's on factory floors, in logistics, or alongside human beings. The sense function is really data gathering function. Robots perceive the real world through various kind of sensors, whether it's cameras, microphones, force sensor, pressure sensor, thermal imagers, or LiDARs. These inputs have vastly different data rates and format, from a gigabit for a video to kilobit for a pressure sensor. The diversity of these interfaces and makes it a complex integration problem. This is where FPGA excel. FPGA can bring those underlying interfaces, process data in parallel, and deliver a synchronized low latency stream to be processed for the next stage. Next stage is making the decision. Raw data becomes intelligence through sensor fusion and AI acceleration. Video, audio, environmental cues, they all must be combined to give context. This is how the contextual AI processing happens in robots. However, it needs to be processed in real time to predict and adapt. FPGA enable deterministic low latency pipelines to offload CPUs and GPUs to ensure decision happens fast. And then finally, robots must act with precision, safety, and security. Moving joints, adjusting torque, or responding instantly to the hazards. Tight control loops and functional safety are non-negotiable. FPGAs deliver precise timing for actuators, real-time motor control, and parallel safety monitoring, allowing robots to move naturally while remaining fail-safe. Every robotics challenge, whether it's bandwidth, AI acceleration, safety, security, ties back to this similar loop. Agilex FPGAs are built to make hardware-accelerated intelligence possible. Robotics is a great example of sense, plan, act challenges. The same needs exist across factory automation, medical devices, aerospace, energy, transportation. These systems need to process massive amount of data, make instant decisions, and act with absolute precision. Agilex combines the best of all worlds: flexible I/O, hardware acceleration, AI, DSP, high bandwidth transceivers, efficiency, and integrated processors. It's the semiconductor platform built for intelligent edge, from robotics to industrial automation to aerospace to energy and many more. Simply put, Agilex is the leading device that meets the performance, safety, security, and the flexibility that these market demands. We can't do it alone. As I mentioned earlier, FPGA is a broad market application devices. And we are strengthening the FPGA ecosystem to reach more customers and make it easier to use our solutions. We are enhancing our global network of qualified solution providers who bring deep domain expertise in the areas that include AI, networking, industrial control, embedded, and more. This network helps our customers to get to working design faster, and we are fully committed to that. We are providing easy access to support and resources, including reference designs, IP, software, and cloud-ready development platforms. This helps users spend less time reinventing the tool and more time innovating. And finally, we are providing access to experts who can help, whether through distribution partners, design houses, or direct. A best-in-class partner network lowers the barriers to adoption and makes technology accessible to more developers across more industries, accelerating innovation everywhere in the world. And we are doubling down our commitment and support to enhance it even more. Altera Solution Acceleration Partner Program is an initiative designed to help companies accelerate innovation and time to market while growing their businesses more efficiently with support from Altera and partners. Altera's partner program unites experts from diverse end markets, including data centers, communication, embedded, and industrial. Today, we have over 300 partners in our program, all focused on developing FPGA-based solutions and driving the innovation across the industries. This program spans a comprehensive range of products and services, from foundational training, IP development, to simulation, emulation, hardware manufacturing, and full turnkey system design solution. This ensures end-to-end support for every aspect of FPGA deployment process. The ASAP program provides the necessary resources and support to help companies tackle complex design challenges and stay competitive in today's rapidly evolving market, driven by the application of Edge AI. We have many partners with us here today at this Innovator Days. Later this afternoon in our Customer Experience Center, these partners will be demonstrating several of their latest FPGA-based solutions. I spent quite a bit of time yesterday with these partners, and I was overwhelmed by the amount of efforts they put together in bringing these solutions together and the comprehensiveness of the solution that they have to offer. I encourage you to visit these partners and see firsthand the innovative solution they have built. Putting these solutions into the hands of users requires a broad distribution network of partners. FPGA fundamental technology touching tens of thousands of customers, and we ourselves can't reach them all. Our technology is only as powerful as our ability to get it into the hands of innovators everywhere in the world. That's where our distribution partners play a critical role. And now, in this new era, we are putting even more focus on enabling our distribution partners. We have a global network that spans every geography, with partners like Arrow, Macnica, Bremec, Istronics, UniQuest, DigiKey, and Mouser. We cover every major geography, ensuring developers worldwide have fast access to our devices and support. These distributors don't just move the products. They bring local design expertise, application knowledge, and technical support, and sometimes even solution directly to our customers. So while Altera is focusing on building world-class FPGA, we are partnering with our distributors to ensure those solutions reach the world quickly, reliably, and with the expertise our customers need to succeed. I would like to welcome Mark Hussain from Arrow to talk about our work together. Mark.
Lost our microphone. I'm just going to hold it, Raghib. 1 second, folks.
Welcome, Mark.
Thanks for having us.
So both Arrow and Altera had two significant milestones recently. Altera's recent independence, and Arrow just celebrated their 90-year anniversary. So congratulations on that.
Thank you.
So Mark, Arrow and Altera have been partners for 40 years now, over 40 years. Can you talk about how customer needs have evolved over this time?
Sure. First of all, congratulations to you and the team on the renewed independence. We've been with you throughout that journey. We don't feel 90 years old. Hopefully we don't look 90 years old either. But we've come a long way since our early days, which was a radio part storefront in New York City on Radio Row. And today we touch tens of thousands of customers globally. Our role has changed. Our role now really is connecting technology like Altera has to tens of thousands of customers, both early on in design and then as we progress through production, through the supply chain. So our role has changed quite a bit. Compute complexity has grown exponentially in that time frame. I'm going to go to a microphone. It's grown exponentially, and that's been fueled, obviously, with the recent rise in AI. And technology has advanced to keep up with that. So we've got smaller density. We've got less power. We've got better performance and more functionality. And all of that opens up the door, right, for us to bring our solutions to many more customers than ever before. And it's exciting, but it's difficult to do. So we accept the challenge, right, for us to go wide and for us to go deep. We do this globally, and we do it through our local engineers in each of the markets that we serve. And we also do it through the 4,000 engineers that are part of our design community with our eInfoChips brand. I would say we need to do that on a global basis because a lot of the design work that Raghib is talking about happens remotely, right? But we need to be able to surface that globally, and we feel we're in a good position to do that today.
Thank you, Mark. You have been a great partner, and we have a common goal to grow, broad market. Share your thoughts about how Agilex 3 and Agilex 5 help Arrow.
Well, first of all, we love Agilex 3 and Agilex 5. So thank you for that. I would say the smaller density mid-market target fits exactly with Arrow's current customer base today. And it allows us to take this enhanced FPGA technology and introduce it to a much more diverse set of customers. As you mentioned, from embedded AI at the high point to industrial automation at the entry level point, we now have a high-end solution. There was a gap, and we love it. So from the customers that we could approach, we're thrilled. I think, as you mentioned, it also puts Altera now at the forefront in terms of the broadest portfolio that allows us to deliver across multiple performance price points, multiple price points, multiple power points. We now have a solution for all of those customers, regardless of where they are in the world.
Thank you, Mark. We are ourselves obviously super delighted about this broad portfolio of Agilex that we have brought to the industry. Can you share some example of how you are helping your customers, our mutual customers, to scale?
Yeah, and that's the challenge. I think you teed it up perfectly in the initial session. Is these can be difficult, right? And our job is to help customers innovate quickly. And how do we take complex solutions that have a lot of power and bring them into multiple different solutions? So we've invested heavily in building out a portfolio of development boards. I've got one of them right here, so you can see the size of this. This is an Agilex 3 development board. And really the intention here is to help all the customers in this room innovate quickly. So this helps expedite the prototype process. It helps streamline development and eventually helps with a faster time to market. The beauty is we've got over 1,000 opportunities together with Agilex 3 and Agilex 5 alone. And so it shows the power that these simple boards can have in helping customers get to market quickly. So as I mentioned, we take our role in connecting your technology seriously. These are a great way for customers to get in quickly and streamline that production.
Mark, I'm super excited about all the work your team is doing and all these solutions that you have put together. So can you explain a little bit how customer can take full advantage of this and how do they engage with Arrow?
Yeah, I'd say step one, enroll in one of the worldwide workshops that we put on. We've actually got one going on in Portland today, so they're real time, they're here. These workshops span all skill level, so introductory FPGA all the way up to complex advanced classes around Altera AI platforms. And there's two ways to do it. You don't have to do it in person. We have the ability for those to be remote as well. So we leverage the cloud, connectivity through the cloud, and you're tapping into our board farm, which allows you to have the hands-on experience anywhere in the world via a farm that we've got built up that gives you interactive capability. So we're trying to make it easy. They're available today. Reach out to your local Arrow or Altera local contact for information about how to sign up for them.
Good. Thank you, Mark. I'm excited about the future that we are building together. Thank you.
Thank you.
So today I've presented about the ways we are growing in the broad market using silicon, software, growing ecosystem, and the distribution. We are also committing ourselves to fully embrace AI. We are committed to using AI across all aspects of our business to improve our operation and developer experience of our solution. So in our enterprise itself, as an independent company, we need to move fast because you need to move fast. And so we are putting the AI into all our design processes and business processes so we can scale at the pace needed to deliver the solution. For you as a customer, we are integrating AI to make our tools more productive for you, so you can bring your projects to market quicker. Imagine where every engineer had a bunch of AI assistant to help them accelerate their development, overall design development. And for the products, we are enabling it. As you have already seen, we are providing you a silicon and software and architecture and to implement, accelerate AI ML. We are making it more and more easier to implement the actual end products, that applications that you are working on today. But we are not stopping here. We are innovating. This innovation will continue to become more powerful in future to handle more and more complex use cases with even more optimized and secure solution. Across the board, Altera is all in on AI. So to conclude, thank you for joining us today and for your continued partnership and trust. We are excited to write this next chapter of Altera with all of you. The world is moving faster. Workloads are changing. Threats are evolving. Opportunities are expanding with the AI applications. With independence, with the strong investor support, with the only US-made high-end FPGA, and with the culture of execution, our opportunities are endless. Our commitment to you is to provide high-quality product portfolio with the best tools and world-class partner network to support cutting-edge innovation and deployment of the solution that are easy to design and deploy at a scale. Today we have put together a great agenda for the rest of the day for you to learn and explore what Altera is investing in and bringing to you. I encourage you to download latest release of Quartus with Virtual Design Studio. Contact your FAE or the channel partner to buy a kit. Explore our ecosystem to aid you in your designs. Go out and change your industry. I hope you have a great day, and I look forward to see you later today at the Customer Experience Center. Thank you so much for being with us today.
Thank you, Raghib. Okay, get your phones out. Survey time. I'm going to stand back so I don't get in the way. You can fill out that survey. Remember, the more chances are to win. All right, just a few questions. Is everyone getting in okay? Nod your head. I'm assuming that's a yes. All right, I can see all the people with the fast typing thumbs. Is that the under 35 crowd? All right. Anyone need more time? Raise your hand. Need more time? Still filling it out? More time? Okay. I'm going to see if we can get caught up here. Got started a few minutes late, but that's okay. For those of you guys who are standing up on the sides, there's a couple seats here in the front. There's two right here. Steve, is there anyone sitting next to you? Nope, 3 seats. Go ahead. Come on down right there. All right. Anyone has got an empty seat next to you? Raise your hand. Okay, people standing on the side, if you guys need a seat, look for a hand raise. Go sit there. Two more seats in the front. Get a chance to ask the CEO some questions. Give them feedback on that Visual Designer Studio. Although we got some folks focused on that, so. We're all set? Okay, thanks. All right, so let's get going. First of all, big round of applause for Raghib. I'm excited. I don't know about you. I'm excited to be back. It's almost like Dorothy clicking her heels 3 times and you say FPGA, FPGA, FPGA. That's what I feel like. All right, our next speaker here, one of the handful of people at Altera that's a fellow. We don't have many of those. He's got a PhD. He's a patent holder. Worked at multiple FPGA companies, so I think he's eminently qualified. He's going to provide some of the data on some of those claims, some of the details, both on the hardware and software side. So please give a big round of applause for Ilya Ganusov.
All right, hope you can hear me okay. Can you not? Okay, sounds good. So we'll have 3 main topics for this session today. We'll first talk about the advancing FPGA fundamentals, and I'll show you how both our power and performance increased over our prior generation of FPGAs, and how do we compare to our competitors right now. In the second session, second part of the talk, we'll talk about AI. Specifically, we'll give you more insight about silicon strategy in terms of how we enhance our FPGAs for AI capabilities. And we'll conclude with the final critical topic of security. So when we talk about FPGA performance, we always, as architects, we like to say, X% faster, 10% faster, 20% faster. But in response, I usually get a question, how fast is it, right? So how many megahertz? So today I wanted to show you a bit more about this and give you more insight about what Altera FPGAs are capable of in terms of absolute performance. So on this chart, I'm showing our internal benchmark suite that we use to optimize both our silicon and our software. So we took about 75 designs from our customers, partners, and from internal designs and plotted them on this chart. Each dot is one particular design. So we took these designs and we sorted them by absolute frequency, and you can see they range from about 50 megahertz for the slowest design to almost 600 megahertz when we run these designs on Stratix 10 FPGA. These designs are selected from different application domains, ranging from ASIC prototyping to wired and wireless communication, automotive, robotics, AI, and high performance compute. So when we take these designs and just take the same RTL and recompile them on Agilex 7, we get this chart. So you see it's quite choppy, different designs speed up by different amount, but no design is slower. Every design is faster. We see at least 10% speed up for the slowest design, and some designs are up to 2x faster than Stratix 10 FPGA. So it's quite a big improvement. When we look at geometric mean, it's about 53% speed up on average, which is the highest single generation uplift in performance in Altera's history. But you still can't quite see the trend. How fast does it run compared to Stratix 10? So I wanted to replot this a little bit differently for you and add RA10 to the mix for a good measure. So RA10 is the independently sorted performance for the, just a second. Hopefully less echo still. All right, maybe I'll speak less loud. All right, so plotting here RA10 on the bottom, you can see Stratix 10 is faster than RA10, and Agilex 7 is absolutely exploding there in terms of performance. This is again sorted independently, so each dot doesn't correspond to each other, but if you look at the median design in RA10 or Stratix 10, it runs between 350 and 450 megahertz. And that's what typically our customers are telling us, that their performance is somewhere in 300, 400 megahertz range. But when you look at Agilex 7, something pretty breakthrough is happening here. So an average RTL is around 650 megahertz or above. In fact, you can see that about almost 2/3 of designs are above 600 megahertz, and 1/3 is above 800. So when you take your design and run an Agilex, this is the performance you should be expecting, above 600 megahertz. And if you see anything different, please come to us, and we'll help you analyze the design and see why it's not taking full potential of the incredible Agilex 7 fabric. So performance is great. It eases your time enclosure. It helps your engineers get to production faster, but it often can be converted to lower power or lower cost. And I will give you an example based on Altera's video IP library. So we provide our customers with a very advanced video IP library, which consists of multiple components. In this chart, I'm showing, for example, 3D LUT, color space converters, scalars, tone mappers, and warp IP. And all of these IPs are qualified to run at least 300 megahertz on Stratix 10 and RA10 and other FPGAs. And in Agilex 7, the same IPs are qualified to run above 600 megahertz. Obviously, when you run at 600 megahertz, it can process double the data compared to 300 megahertz IP. So for one 600 megahertz IP instance, you would need to instantiate two 300 megahertz IPs, right? So, and 600 megahertz will consume less resources, and you can see it on this chart. If you run at 600, you'll consume on average about 1/3 to 35% fewer resources than if you run at 300. So this potentially can enable you to use a smaller FPGA compared to an FPGA when you run at 300. And here's a hypothetical example where if you move from AGF027 FPGA to AGF014, you will save 8 watts of power, mostly due to static. Of course, dynamic power will be higher because you're running at a high frequency, but still it's pretty big net savings. So it allows you as our customer both to save on operating expenses by consuming less electricity, as well as capital expenses by using cheaper, a smaller FPGA. So when we talk about converting performance to power, and power usually gives us less electricity, OpEx, as I said, as well as you can use a longer battery life for some of the embedded applications. And that's conventional ways we look at power. But saving power is a lot more than this. And when we talk to our customers, they see many more savings, especially when we talk about embedded applications, which has to fit on very small boards with a limited real estate space. So on this image, you can see a very small Altera 6825 nano board, which just was publicly announced last week. It looks big on a slide, but it's really quite small. It's about 7 by 10 millimeters board, and it packs, just crams it with different components. FPGAs at the center, but there are different serial interfaces, components, passives, and so on. So when we deliver lower power FPGA, we allow our customers to use smaller packages for our devices. This board can use smaller batteries. It can also completely eliminate heatsink in some types of applications, or use smaller or cheaper heatsink. Overall, lower power reduces the PCB area, extends lifetime, and allows our customers to meet safety and efficiency certifications much easier. So what if you cannot convert extra performance to low power? What if you are happy with your current performance? Let's say you run at 500 megahertz on Agilex 7, and you're pretty happy with it. So you can run the same frequency as a previous generation, Stratix 10 or RA10, and you will still get power savings. We invested a lot of time and effort to make sure that Agilex 7 fabric is 2.5 times lower static power consumption than Stratix 10, and it also achieves 22% reduction in dynamic power. So no matter what your frequency is, you will get quite significant reductions in power now on our current generation fabric. So when we showed all these comparisons, they were all against our own FPGAs. So how do we compare against competition? First, on speed, we profile all competitors of FPGA, and the closest FPGAs which come to Agilex 7 in terms of speed are AMD's Versal and AltaScale Plus FPGAs. So we took the benchmark suite that I showed to you earlier and compiled about half of them on a competitor's FPGA. And when we do that, we see that Agilex 7 is about 20% faster than Versal FPGAs and about 35% faster than AltaScale Plus. When we look at power, at the same frequency, we see about similar trend. We're about 25% lower power than Versal and about 30% lower power than AltaScale Plus. So whether you look at performance or power, Agilex delivers the world's fastest and most power efficient core fabric. So no presentation today goes without mentioning AI, so dive into this. Let's dive into this and look at our silicon architecture. At the Innovators Day last year, we did a detailed walkthrough through Agilex 5 floor plan, highlighting core fabric in the middle, advanced peripherals on the top, bottom, transceivers on left, right, ARM core subsystem, secure device manager, and so on. But our AI runs in core fabric. And the key to AI on Altera FPGAs is a reconfigurable DSP block, which is integrated in FPGA fabric with the AI tensor mode. The AI tensor mode block combines traditional DSP functionality with AI functionality. In traditional DSP block, we can do 2 floating point multipliers in a single cycle. And those 2 floating point multiplications can be added and optionally accumulated with the previous result, which is a very common operation in AI workloads. With the AI tensor block, we can reconfigure the same DSP to do 20 floating point multiplications per cycle. It's 10x more dense in terms of floating point compute compared to traditional DSP block. We introduced this block in Agilex 5, and we also proliferate in this block in Agilex 3 FPGAs. So our full portfolio of mid-range and low-end FPGAs include this block. So one can ask, what's the big deal? You just took a DSP block and just instantiated more multipliers. It's really not that hard. But the difficulty of doing this is that all the inputs and outputs have to go to the same fabric as in a traditional DSP block. So you cannot add 10 times more inputs and still be able to route FPGA and close timing. So it required multiple innovations in this particular block to be able to pack so much compute and still provide routable FPGA. And let's look at all those innovations that we put in. First, we switched from brain floating point 16-bit format to a block floating point 16-bit format. What the block floating point does, it actually shares exponent between multiple values. In Agilex tensor block, we split all 20 multipliers into 2 groups, and each group of 10 operands shares one 8-bit exponent. So this allows us to reduce number of inputs by 2x compared to using conventional brain floating point format. The second innovation is preloading the weights. As you know, in AI, the most common operation is matrix-matrix multiplication, and when you do matrix multiplication, you usually fix a row of one matrix and traverse over the columns of the other matrix. And because of that, the row, one of the operands is fixed. So therefore, we can preload the coefficients of the row or the column and just stream the activations through the tensor block. By removing weights from the main route and data path, we can reduce the number of inputs to DSP by another 2x. Finally, one of the unique features of AI computations is that you usually compute multiple filters in parallel. So the activations can be broadcasted to multiple multiplications at once, and that's the final innovations in the AI tensor block. When we bring the activations, we actually fan them out to 2 rows of multipliers at the same time. So we reduce the number of bits coming in by another 2x. So we get 2x reduction in inputs from block floating point, 2x from weight preloading, and 2x from activation broadcast. And all of these optimizations are required to make AI tensor block work. On this slide, we show the full range of precisions supported in our DSP block. You can see that we support all numeric formats for all kinds of applications. On the bottom, we have general purpose floating point formats, which are IEEE standard. In the middle, we have formats which are common in wireless communication workloads, such as 18-bit integer, which is a bit unusual, but wireless communication guys love it, just to get a bit 2 bits of precision on the integer format. And Agilex 7 FPGAs support 3 different formats for AI, namely FP19, TensorFlow 32, BFlow 16, and 9-bit integer. In Agilex 5 and Agilex 3, we added 2 new formats. One is the block floating point, which I just talked about, and another one we don't mention often, but we also added another format for wireless communication, which is 16-bit complex integer multiplication. So not only we enhanced it for AI workloads, but we also pay very close attention to other application spaces as well. So everybody, including FPGAs, is increasing AI compute in their silicon, but there's a problem emerging. And I think FPGAs have a very unique advantage to overcome this problem. On this chart, we're plotting the capability and efficiency of the best performing silicon on Resonant 50 inference for a single stream scenario, which is very common in embedded applications. In the blue bar, you see the peak tops for the best performing silicon in MLPerf. And you can see that every year, the best performing platform packs more and more compute. The best one right now is at about 2 teraops in terms of int8 tops. However, if we look compute utilization in terms of how much compute is actually being effectively utilized to do useful compute, that number keeps dropping every year. So as vendors add more and more compute, that compute is actually less and less useful and less efficient. And here we have a problem, right? So it's very easy to add multipliers, but using them efficiently is quite difficult. So by integrating AI tensor block in FPGA, we think we have a very good solution for very effective use of the compute that we add. And to demonstrate this, here's a data that work that we created with our partners Heronic Technologies, where they can compare inference for Resonant 50 running on Agilex 5 FPGA using Heronic's IP and compare it to the leading embedded GPUs for a single stream Resonant 50 inference scenario. So the characteristics of these platforms you can see on the right. We're using the same precision of int8, achieving about the same accuracy after quantization, but the peak tops are quite different. Heronic picked Agilex 5 D part at 16 tops, and we are trying to compete with NVIDIA's GPUs with datasheet tops ranging from 50 tops to 275 tops. So it looks like we have no chance at such low tops. However, if you look at the real data on the left, you see that Agilex 5 achieves almost twice the frames per second inference on this benchmark compared to other GPUs. And the reason for this performance at lower peak tops is because we are able to utilize more than 60% of DSPs very efficiently. If you want to find out more details about this particular study, feel free to take your phones right now, take a QR code, and download white paper, which gives you a lot more detail about the setup, about how this performance evaluation was run, and how these results were achieved. One of the other advantages of integrating AI directly into a DSP block is that we can offer high-performance AI in every FPGA that we ship to the market. And on this chart, we show the full range of capabilities of our devices, specifically for Agilex 3 on the left, Agilex 5E in the middle, and Agilex 5D, our highest performance mid-range FPGA on the right. Agilex 3 ranges between 30K logic elements to about 150K logic elements and provides up to 2 teraops of compute for very low power, low form factor, very efficient AI. Agilex 5E covers a very wide range of FPGAs, about 10x, spanning from 50 KLE to 600 KLE, reaching tops of about 32 tops. And finally, Agilex 5D is our top performant FPGA in the mid-range FPGA space, reaching almost 150 tops. In fact, those last 3 dots were not there till today. Today is the first day we're announcing availability of those FPGAs. And if you want to find out more about these 3 new FPGA members, once again, please feel free to download the new datasheet we just published this morning. Those new FPGAs feature up to 1.6 million logic elements, and as I mentioned, up to 152 int8 tops. So we talked about inference on FPGA and how AI TensorBlock makes it very efficient. We can address a lot of different application spaces, ranging from wireless communications to robotics, to medical imaging, military and airspace, and so on. So we can run inference for edge AI, we can run inference for generative AI or custom AI workloads. But FPGAs are not only useful when you run inference, they're also very useful to help other types of silicon to run inference efficiently. For example, FPGAs are very often used for data connectivity to provide networking capabilities to other types of silicon, or they can be used for data pre-processing for GPU or ASICs, which run.
That's sick. That's sick.
All right. So as an example, we partnered with D-Matrix, which is known for shipping extremely efficient and fast inference accelerators for data center and edge. And they're using Agilex 7 FPGAs to provide connectivity support when they need to run inference across multiple pieces of their silicon. Here's a quote from Sriya Ganesan, who is a VP of product at D-Matrix. Napatech's Altera Programmable Network Interface Card enables D-Matrix to deliver efficient, ultra-low latency distributed inference across multiple servers. Our customers get the benefit of deploying an industry-standard Ethernet-based scale-out solution while taking advantage of D-Matrix's Corsair's blazing fast inference speeds. So no matter where you use Agilex FPGAs, they can help you accelerate inference, accelerate networking, or accelerate interface. And this brings us to our last critical topic, which is security. And I wanted to start by looking at cybercrime as its own industry. According to Statista, in 2025, cybercrime, if it was its own economy, would reach a cumulative GDP of $10.2 trillion. It's quite mind-boggling number. And this number is growing. By 2028, this number is supposed to grow to $14 trillion. So it's catching up and will be #1 economy in the world if we don't do anything about it. So at Altera, we're really focused on this, and we have been investing in security for many years. And when you look at traditional attack vectors on FPGA, such as bitstream cloning, design spoofing, or reverse engineering, we see the sophistication of these attacks keeps growing every year. And with the deployment of AI tools, we see these enhancements and this sophistication of our adversaries will only accelerate. At Altera, we work very closely with our partners to navigate them through evolving field of security regulations and standards. And our security experts are actively participating on multiple security committees, such as EU's FPGA Working Group on Cyber Resilience Act. And as I'll show on the next slides, we've been investing in security for multiple generations and building on top of previous layers of defenses consistently. We also believe that FPGA is the best platform to accelerate conversion to post-quantum security. The history of FPGAs and security is quite big, and I can't quite go all the way back, so let's start with the Cyclone FPGAs. So Cyclone FPGAs had basic security for bitstream encryption, as well as ability to control JTAG to prevent readback of the device. In ARIA 10, we enhanced these capabilities with side channel resistance, and we also provided customers with capability to put their own security programming into fuses or battery-backed RAM. We also provided ECDSA-based SoC boot authentication for the devices with the ARM core subsystem. So ARIA 10 and early devices, like many devices of that era, used hardware-based security, which means it was all based on hardware state machines. So if there was a new threat emerging, there's nothing we could do about it. The security was burned and programmed into silicon. As we saw the emergence of new threats when we were working on Stratix 10 FPGA, we decided to completely revamp security architecture to make sure it's updatable if there's any new threat emerging. So to enable this updatability, we transitioned from using hardware state machine to using state-of-the-art processor-based security, where the security and configuration was based on the combination of processor and the firmware. So if there was a new security threat, we could always upgrade the firmware to change our configuration scheme or use new encryption algorithms and so on. So Stratix 10 was our first FPGA which introduced Secure Device Manager. In addition to that, we introduced for the first time black key provisioning, where our customers could request us to transition keys in our manufacturing environment securely to FPGA during manufacturing. And we also, for the first time, enable PUFs, or physical uncodable functions, for better bitstream encryption. In Agilex generation of FPGAs, we proliferated SDM-based architecture across all our product portfolio, from the high-end Agilex 9 and Agilex 7 to Agilex 5 and Agilex 3. We also enabled new capabilities, such as crypto services, where SDM could provide encryption services to Fabric or to processor subsystem. We also enabled FIPS certification, ownership transfer, and in Agilex 5 and Agilex 3 devices, we enabled SPDM secure channels, which take black key provisioning and enable us to do it not just in our manufacturing environment, but to give to our customers so they can securely transmit encryption keys at any place at any time. And finally, just 3 months ago, we announced that select devices in Agilex 5 and Agilex 3 FPGAs will support post-quantum encryption, including LMS, MLDSA, and hybrid schemes. In these FPGAs, we leverage the flexibility of Secure Device Manager and the fabric itself to enable quantum agility and post-quantum encryption. To deliver on our promise that we think FPGAs are the best platform to transition to post-quantum as soon as possible. To conclude, for Agilex, we designed our best, fastest, and the most power-efficient core fabric, and we use the same core fabric from our high-end to our very low-end devices. This enabled us and our customers to use the same IP no matter which market you target. We have also upgraded our core fabric with an AI tensor block, which increases the compute density for floating multiplication by 10x, while continue to be able to be routable at the very high performance requirements. We rolled out AI tensor block across all our mid-range and low-end FPGAs, enabling our customers to pick from 18 different unique FPGAs in that range. And finally, we believe that security should be part of every device, and we have built increasing levels of defenses and security in every product that we have shipped in the last 10 years. And we are supporting post-quantum cryptography and agility in our Agilex 5 and Agilex 3 FPGAs. So today, I talked mainly about silicon architecture. Of course, software is a big part of the solution. So if you want to find out more about how we enable all these AI capabilities in our silicon through software, please feel free to go to this link and watch a short video about FPGA AI suite. Or even better, please feel free to attend some of the AI sessions that are scheduled for today. Thank you for being here today.
Thank you, Ilya. We don't have time for questions, so go ahead and get your phones out, fill out the survey. And when you're done, you got a 10-minute break. So fill out that survey, head outside, 10-minute break, and then come on back.
Yep. Okay. So let's try that again. Oh, and I've moved the camera as well. Joy of joys.
You're good.
You're good. Okay. We are the technical difficulties coming to you live from Altera. Yeah, so that was the two presentations, one from Raghib Hussain, the CEO. He covered some of the new announcements, and also the second one from Ilya. And that was a really good presentation, I thought.
It was a lot more deeper in terms of technical details.
It was really weird a little bit for us because we have a fleeting engagement with FPGAs compared to some of the other stuff in the industry.
That's fair.
But it just goes to show you kind of how complex these chips are. Right?
Yeah.
You have to have as much consideration for an FPGA as you would do a CPU or a GPU or an ASIC. But yeah, so Ryan and I plan to spend roughly the next hour. We're going to go through, we've taken copious amount of notes. You might see us look at the blackboard or the whiteboard over there. Blackboard. That really does make me sound old now, does it? And we're expecting one or two executives to come through the door and join us in our third seat, where we get to ask them some questions. So as people come in, please do put your questions in the chat, and if they have time, we'll put them to them. But first of all, let's go through kind of what was announced and what we think of it. So first up, we finally have all the Agilex shipping.
Yes, I feel like they announced some of these chips ages ago. It's been a long road actually getting it all out the door. But yes, according to Altera, they finally have the entire Agilex family shipping 9, 5, 7, and 3.
And a lot of the different variants of therein as well.
Yeah.
I mean, I remember it must have been 2017. Back then, because obviously under Intel, they said, come to our office in, is it Slough? And come speak to the head of our FPGA team who had just flown in that morning.
Oh.
And so I live within driving distance, so they booked a car for me. I still have that picture of me taking a bite of what was the Stratix 10 back then. But I remember that conversation being all around, the rollout for Agilex. And it seems weird to say they announced it that long ago.
It really has been that long. I mean, all this new stuff is built on the Intel 7 process. Stratix 10 was an Intel 14 product. So they've only finally made the node jump from Intel 14 with the new Agilex gear.
Well, it's some of the Agilex, the first ones that came out were Intel 10. Or they were designed to be Intel 10, and then obviously problems with the node pushed them out. It's we got to assume this is the most advanced version of Intel 7 as well.
Oh, it is.
Yeah. So
it's interesting timing though, because as I'm sure you know from Intel's financial reports, Intel 7's manufacturing capacity is completely maxed out right now.
Yeah,
They're building all the Intel 7 wafers that they can.
It turns out simple packaging is cheap.
It is, but it also means Altera is getting their hands on what right now are some very valuable wafers out of Intel.
Yeah. I mean, we covered this briefly before the keynote, but for FPGA companies, their revenue is still pretty much in the legacy portfolio. A good 80-90%. We expect. Unfortunately, because Altera is still a fully private company, we won't get those numbers.
Yeah.
Back in the interview with Raghib, you highlighted it before, the $1.5 billion of revenue in 24. So that gives us a little bit of a platform to work towards. Now, the key product announcement, aside from all Agilex shipping, is Agilex 5D.
Yes.
They already had 5E out in the market, and this is 5D. Do we know what E and D stand for?
They stand for different market segments.
Okay, so edge and data center, I imagine.
Yes. The 5D is roughly aimed at the video market, 4K, 8K video processing, certain edge applications, etc.
Okay. Yeah, so we've got a list up here of notes. So Agilex 5D ranges from 500,000 logic cells to 1.6 million logic cells.
Which is absolutely huge for a mid-range product.
Yeah. I mean, Agilex 5 is meant to be that sort of mid versus Agilex 7 and Agilex 9. And you're saying, well, Agilex 5 goes up to 1.6, which is really where 7 should be, sort of thing. But it's always a mixture of features, right? And on top of that, they've got, I highlighted two main features that are coming into that product. We've got post-quantum cryptography, hardened in. So all the new standards from NIST we discussed before the keynote as well. But also this AI tensor mode. And while we were watching it, Ryan and I were discussing about how other FPGA companies are now doing hardened AI DSPs in their FPGAs.
Correct.
So this is, I guess, Altera's attempt to do something very similar. But where I've seen it in other FPGAs, it's been a dedicated block or it's diagrammatically showcased as a block to the side of the programmable fabric. Here,
it's in the programmable fabric.
It's in the and well, when we say fabric in this case, FPGA companies call the compute part the fabric, and the networking is the interconnect. Just
not confusing at all.
No. So normally, so in this case, we have logic cells, and then I guess as a function of an area of logic cells, there is AI/DSP functionality to enable tensors, tensor compute. So we saw actually some really good diagrams, I felt, from them explaining how it works using very traditional FPGA logic flow diagrams. But in this case, they say they're supporting integer 8 and FP16. And we have our first guest. If you're ready, would you like to join us? We're actually just going through all the notes we made from the presentation.
Thank you.
So please come sit. Come sit. So joining us as our first guest is CEO Raghib Hussain. How's it going, sir?
Going great. I am super excited with a lot of innovators and developers, and as I said earlier, I love to interact with them. I already mingle with them, and very interesting discussion. People are very excited about having access to full Agilex portfolio and having all the new ability that we are bringing to the market.
So I didn't see how many people were in the room.
So the room was at its capacity actually, which is about 200 people. But then we had extended area, so we have in person here about 500-600 people.
So I mean, from me, explain what you want to get out of this event.
So our goal is to really, of course, you must have seen the press releases today. We have really, released our new tool, Quartus Prime 25.3, which comes with a Visual Design Studio with a lot of additional features and so on. And we have also released the new expansion of Agilex 5 and Agilex 3 devices in full production. So now with that, we have the complete Agilex family in production. And in addition to that, we have industry-leading tool, which allows developers to accelerate their overall development and reduce the time to market. So our goal is to give first-hand experience and also connect these developers with the innovators with our partners. So if in our customer experience center, we have lots of partners today which has brought their own solution and bringing design. So that community is actually where this discussion goes and innovation happens.
I was saying to Ryan, that's something we have to go through later after we finish the stream.
Definitely.
Because
you should spend some time there. I spent like several hours yesterday, and it's always fascinating talking to folks who have developed themselves the complete end solution for a variety of markets.
So from my point of view, so now that Agilex is fully out, how should we think about Altera's revenue distribution between the older product line and the Agilex product line?
So obviously these FPGAs are the very long life, right? So even the older product line is only 10 years old. It's not even 10 years. It's like 5 years old, right? So many of those, in fact, are getting new design or even ramping. Even this year are ramping. So and then at the same time, we have tons of design in Agilex, which is supposed, which is expected to ramp in the coming years and so on. So we already have significant revenue with the Agilex line. We do not disclose the percentages, but you can see that Agilex it started going in production, let's say, a few years ago. So those designs are ramping, and we have a very good traction for Agilex. Initial designs were mainly in the the aerospace defense application, Agilex 9 and the Agilex 7 and in the data centers and the test equipment and so on. And now with the Agilex 5 and Agilex 3, as it started coming in production, we see a huge traction in the broader market. And also with the focus of being us being independent on the broader market, that also helps.
Yeah. Now, the other big part of your presentation was on the software side of things. a visual designer studio. Your guys seem pretty excited about that one. It seems like a pretty big project from you guys. How long have you been working on that one?
So this is a project which has been going on for several years, and I'm really pleased to see the outcome. And in fact, when I joined here a couple of months ago, this was one of the key thing. We wanted to release it by this time frame, and I wanted to be in a production and fully released. And I must say the team did great job in working long hours and making it happen. This takes the user experience to the next level. I mean, the way it should be, in my opinion, easy in a visual way, just like Adam Taylor explained, that as an engineer, you would like to have more and more visual tools in today's modern world. And that's what we are trying to do.
Oh, very cool. Very cool.
Talk us through what exactly the AI strategy is, because I've had a go at companies before who take their whole portfolio, put a big circle around it and say AI. Can you kind of sort of like drill down into what that means for Altera?
Yeah, so that may have been in many companies, and you are absolutely right. A lot of companies just adding a .ai instead of .com to call themselves AI. I personally am very big believer of AI. In fact, I was early adopters of in my personal life, at my home as well, of using AI tools. I was kind of a sponsor at Marvel also to implement AI, not only inside, but of course focus the overall our business on the AI infrastructure and so on. So that's I'm bringing the same level of I should say the spirit over here, where we want to use AI. The AI is in a 3 different ways. So one is internally, how can we use latest AI tools to really modernize our own internal business system? How can we, get the information flow fast and the real intelligence coming out to be using AI tools in all of our business systems and increase the productivity of the team. So that's internal, not only on the business system side, but also development side and the actual silicon development and the software development. How can we expedite? So that's one angle. The other angle of AI is how do we use AI to enable better experience and better support for our customers? So that is a huge focus which we have. That's an initiative I started right after I came here, and we will disclose more and more as we go forward, as we bring those solutions to the market. And then the third one is how do we make the AI application, the end application, easy? And this is where Agilex is the FPGA, which has tensor accelerator infused in in the fabric itself. So it's not like a coprocessor. It is a part of the design. It is part of the design. The normal IP in the FPGA itself. Yeah. So that is very helpful in enabling easy adoption of the AI. Sorry about that.
No, it's all right. You're a very busy man.
Yeah.
So for anyone watching the stream today, what should be their takeaway from seeing your talk and Ilya's talk and what we're discussing?
Well, I just want to tell everybody that this is new Altera. We are, bringing back the extreme focus on the customer needs, as well as the implementing pure engineering culture inside the company, and we want to give the same experience to the customer. Because in my opinion, our whole purpose is to enable all these developers with the best products out there, with the best quality and the ease of deployment. I love to work with all the customers to create value, solve complex problem, and that's the culture you will see moving forward. Having easy access to our devices, having easy access to the support and solution through our partners and distributors all over the world, and having the fast response time and quick decisions. So that's what you should expect.
And we've got the guy from Arrow, I think, coming later. What should we, on your behalf, what should we get him to do?
Well, Arrow has been a great partner, and they have already committed to step up and expanding, taking all of our these products and going to the broad market and telling sharing our story and giving our access to our product and solution to the broader customer base out there. So they are a very critical partner for us to take our solution and product to the broader market.
Awesome. Well, thank you so much.
Thank you.
Thank you. And we'll definitely enjoy the rest of the day.
Definitely. It's an exciting day. A lot of good talk, a lot of good presentation in the customer experience center.
Absolutely.
Thank you.
Thank you. Yeah, I think we're going to get the Arrow guy coming by later, so to have a chat. So what do you think of Raghib?
He comes in an interesting, comes up with an interesting job. He's technically an outsider of this company. He was only hired back on May, I believe it was.
Yeah, it's been 3 or 4 months.
Yeah, so previously to that, he was at Marvell and Cavium. Wasn't really doing FPGAs, so he comes in from an outsider's perspective, but that may very well be what Altera needs, because while there's there are a lot of resources here. I've been talking to people who've been with the company even before Intel acquired them back in 2015. It's not necessarily a group that has the same sense of self in 2025 that it did before the acquisition. So coming in with somebody who is new to this scene, maybe just what they need. And he certainly comes in with a vision, this customer-centric focus that they are going to need to succeed if they are going to go into a growth mode and pull market share from other players and sort of reestablish the funnel needed to bring new customers into the company that wasn't happening under Intel's control.
Yeah, sounds good. I think Mark is ready to come in. Yep, we're ready. Hey. Welcome to the setup. Mark, please take a seat.
Good to see you.
Yeah.
Pleasure to meet you.
Sorry, Mark. Ryan, Mark.
Ryan.
Ryan used to be my boss.
Okay.
Now he's working for me.
Busy.
Yeah, that's how it goes. So unfortunately, your presentation didn't come through loud enough on the stream. So can you go over what you were talking about and why it matters?
Yeah, happy to. I guess there were 2 milestones we were celebrating: 40 years of us being a partner with Altera, and 90 years for Arrow as a company.
That sounds insane.
Isn't that crazy? Yeah.
Hopefully
we don't look that old.
What were you guys selling 90 years ago?
It's amazing. We were a radio parts storefront on Radio Row in New York City 90 years ago. So we've evolved quite a bit. That was the question. We're now supporting tens of thousands of customers globally. And our job is to take Altera's technology and expose it to those 10,000 customers. And I think, as Raghib was saying in his opening, they're dependent on the reach that we have. And then we talked a little bit about what's happened from a technology perspective and how fast that's advanced and how difficult that is for customers to be able to adapt and understand and learn themselves, and the role that we play in bridging that gap.
So how does your relationship evolve now that Altera is independent?
Well, it's the beauty is, over 40 years, we knew what that was like when they were independent originally. For us, a lot of the recent product introductions around Agilex, which they're talking about, that hits the sweet spot for us that was a gap previously, right? So that lower density mid-range market allows us to take FPGA technology into a really diverse customer base. And so I think the need for us to partner together is stronger than ever. The product portfolio that they're now focused on is directly in line with the customers we currently support. And now our job is to show them how FPGA, right, can scale them quickly. And I think that's one of the things we talked about. I may even have it here. This is our cool gum stick development board. And really, we spent a whole lot of time and money to figure out how do we expedite our customers' time to market. There you go. Yeah.
It's chips, right?
It's chips. You might watch your teeth there. But yeah, it's how do we enable customer development to happen quicker? And it's really we've got, I think today, a couple thousand opportunities already on the Agilex 5 product family with them for customers that frankly didn't have access to FPGA before. And so it's fun.
I think people don't realize that you're one of the lead partners in actually designing and creating dev kits for these chips.
Absolutely. Yeah. We've got a series for 3 and 5 today, and it'll be 7 and 9 by the end of next year. And yeah, I think from our perspective, we're able to pull a bunch of different technologies into these boards, and we support all of them. And then the customers are not just getting the dev kit, they're getting our team of engineers with it.
So you have FAEs that go and help.
Yeah, so our job for Altera is across the globe, we've got local application engineers. Some of them are FPGA specialists.
Okay.
And so not only are they getting the dev kits, but then they've got a resource to use to help them with the design. And then we acquired a company called eInfochips, which is a design services company. Very, very capable in FPGA. And there's 4,000 engineers that are part of that. So
that's bigger than Altera.
Yeah, it's big. Yeah. So there's customers that say, hey, I love the technology, but how do I get help porting the platform?
Okay.
And so we can do a lot of that on the front end, and then we can actually help with design. So we're a great partner to take a complex technology and drive it into customers that are broader than Altera themselves can support.
I know the process is refined, but realistically, what is the successful execution of that sales funnel?
It's largely dependent on, for us, the diversity of our customer base is so broad. So we play in industrial, we play in robotics, we play at the high end in AI, and the needs of those customers are very different. The conversion of the funnel with us involved is pretty significant. Probably get in trouble if I quote percentages, right?
Sure.
But I would tell you that there's a hands-on element to FPGA that are critical. So front end, and then our ability to invest in the inventory ahead of time. When these customers' time to market is critical, they don't have a huge cash flow. So we've got parts ready to go before their design is even finalized and ready to go, right? So all those things we do are maximizing. It's quickening their time to market, but it's guaranteed a high rate of success.
Does anything change now that Altera is committed to perhaps a faster product cadence?
Yeah, I think it opens up a huge customer set as a result of that. Previously, right, the direction was at much higher density and a much smaller customer footprint. And so, yeah, their ability now to go really anywhere. They have low end. We talked about Agilex. This is mid-range, and they've got high end. And I think the complication with FPGA is it's not just a socket for socket replacement. You're meeting with customers and saying, we're going to take 7 or 8 of those parts, and we're going to customize a solution for you. And while it's exciting, it's daunting at the same time, right? And by the way, if you don't get it right,
you match set as well.
It's pretty risky for the customer. So you have to convince them that the technology is great, but is the ecosystem and is the support and is the longevity something worth them making a shift? I think the beauty is Altera's track record. We're back to kind of where they started in terms of a leading edge, independent, technology-driven company that's focused on the FPGA solution versus something that was part of, right, a different set. So anyway, we're excited, and we think it fits really well with what we do and have done for them for a lot of years.
Anything you want to ask, Ryan?
I kind of stole my question right there earlier, so I think I'm good.
It's so funny thing. You don't know this. Here's something I'm gonna. So Arrow owns a company called AspenCore.
Yes, they do.
Who owns a brand called E Times.
Yes, they do.
With their senior reporter Sally Ward Foxton, I actually do a show with her on the channel called the AI Hardware Show.
Oh, great!
So we're actually connected more than you realize.
Yeah, it's a small world, isn't it?
Yeah.
So I mean, it's we've owned those properties for I'd say more than a decade now.
Mhm.
And we didn't talk about it, but that is another way that we can help evangelize the message, right?
Mhm. Yeah.
We appreciate folks like yourself taking an interest in technology and FPGA. Makes it fun.
It's one thing that keeps coming up in my comments, and the viewership is broad. Anything from large, the Intels, the AMDs, the whatever, all the way down to the hobbyist. Does Arrow do anything specifically to enable like the hobbyist FPGA developer with a partner like Altera?
Yeah, so we kind of ended the session earlier around our workshops, and so we've got global workshops going on. We've got one in Portland today, so they're real. Okay. They're up and running.
Yep.
These workshops span from introductory FPGA education all the way up to the advanced AI, Altera AI platform. So customers can attend live at a location near them. What's really cool is they can also have that same experience remotely. So we've got a board farm where we've got all these boards plugged in and connected through the cloud. And so customers remotely can actually do hands-on work while they're remote. And so there really isn't any limitation, right, to getting access at an early skill level or even an early customer development.
So if they can't immediately shell out a few hundred or a few thousand for an FPGA, you have
cloud connection, and we got you covered.
Oh, that's amazing. I also have one photo to show you. And unfortunately, we can't show this on the stream, but this was me visiting the Altera UK office a few weeks ago. And so I don't know if these are part of what you provide, but they obviously have these dev kits. This is an Agilex 5.1. It's in a box like a commercial motherboard sales thing would go. We didn't know they did these.
Yes.
And I said to the people in the office, why don't you tell people you have them? Because we have an audience who would definitely like to see the inside of what a dev, if someone was to buy a dev kit, even if it's only one unit, right? What do you get inside? What's the hardware look like? What's the integration look like? What's the connectivity look like? So if I have one request, it's if you do the things that you have that look like this, tell people that they exist, because I think sometimes that message gets lost in the fact that a lot of sales end up at the big customers who want lots of product, but realistically, the people making lots of noise.
Well, and they're the ones who need the support, right?
Absolutely.
So yeah, maybe it's a great call out. Thank you. Maybe we'll do an interactive session where we actually kind of do a what's inside.
Yeah.
And we just walk through all of the different elements, and then talk about the follow-on, which would be these workshops where they can then go and play with them hands-on.
It's an extension of the funnel.
I appreciate it.
I'd watch that.
Yeah, absolutely. Awesome. Well, thank you so much, Mark.
Nice to meet you.
Yeah, you too.
And nice to meet you as well.
Thank you for the time.
And good luck.
Got it.
Yeah.
I'll leave you with a stick of gum.
Oh, thank you very much. This will go into the collection. It's the collection's getting quite broad now. Awesome. Thank you, Mark. Well, that was Mark. He's president of I should have said right at the start, president of Arrow USA, and has been in charge of as we went through the sales funnel of what FPGAs do. He spent 11 years. We were actually looking through his LinkedIn earlier. He spent 11 years there, 12 years at another distributor, a competitor to them. And I'm not sure how often you interact with salespeople.
Not that often.
No, it's very interesting, the view they have of the industry, because obviously
they look at it in a very different sort of way.
I'll go to a company and they'll have their sales rep for Hewlett Packard, right? And that person's job is just to sell to Hewlett Packard. And it's almost insane that that's one person's job. But when you have these big when you're partnerships,
buying tens of millions, $100 million and stuff every year,
it's having somebody on staff that you're paying $250,000 to ensure that there's less friction in that sales funnel makes sense. It's if you've never visited the Arrow website before, have a look, because it will have 100,000 items. Right.
Oh yeah, it's absolutely massive catalog. If it wasn't for the fact all this stuff was so small, I don't know how they'd fit it in a warehouse.
Well, distribution. They're a distributor, right? It makes sense. It's good to hear that they're doing the workshops, because as I said, a lot of the hobbyists out there kind of feel a little bit left out when it comes to FPGAs.
I had no idea that they had 4,000 engineers at Arrow.
Yeah,
that's absolutely massive, especially compared to, like you said, Altera is
2,500.
2,000 engineers.
Oh yeah. He didn't say all the engineers were FPGA.
True.
And they do sell 100,000 products.
Yeah.
So
but still, I didn't realize as a distributor they had that much of an engineering staff.
Yeah.
So. It goes to show how important the Mouser-Altera relationship is. Altera is, they're a standalone company, but Mouser is doing the heavy lifting to get their stuff out to everybody who's not a Fortune 50 company.
Yeah. They're not a distributor, really. They're an engineering company that just happens to facilitate sales to a certain degree.
We're looking at it.
Yeah, and when he said, 90 years ago, radio parts, my mind instantly went to, wait, was Radio Shack about then?
There you go. You outlived Radio Shack.
Yeah, which wasn't a UK thing, by the way. I only know that through media coming through the US. So going back to the Altera announcements, we were just about to breach the topic, and Mark also touched upon it. The whole implementation of AI in the fabric. In this case, Altera was talking about having block float support, which other companies have struggled to get into their silicon. So it's good that they're doing things like that.
It's one of the core components to getting any sort of foothold in the AI space. Everybody is going to need block format support. Everybody is going to need some sort of equivalent of tensor core or other deep systolic ALU. It's just that is the required hardware to get in this space. And if you listen to the AI guys, at least AI is not going anywhere but up.
I did notice a lack of FP8, which is what we're seeing on the leading edge of inference. Do you think that's just the timeline, the design timeline, just didn't intersect?
That is. Remember, we were talking about this earlier before we came back stream, how long it took to bring the Agilex products to market.
Yeah.
These were announced half a decade ago or more, and they're just now finally shipping in volume. So you're looking at decisions that were made half a decade ago.
Mm-hmm. I also think that if you look at most of the workloads they're talking about, it's not tokens, it's not transformers, it's more about convolutional neural networks,
computer vision, things like that,
which arguably is integer-based workload, and they are supporting block float integers at least. We saw on the slides int 8 and everything else. Yeah, block floating point 16 and block 8-bit integer. So at least for those workloads, it makes sense. They were giving out TOPS numbers for 8. Normally people talk about floating point 8 TOPS. FPGA land talks about 8-bit int TOPS. So there's a little bit of complexity difference in those two numbers.
It's always hard to compare TOPS numbers between vendors for that reason, but at least Altera is being consistent here. They're using int8 TOPS in all their claims. So 3, 5, 7, you can always compare them and you're within the same base.
Have you seen the image of the duck with a knife saying from Untitled Goose Game, and the caption is TOPS at what precision?
No, I haven't seen that one.
It's a little meme that's going around the AI community because people keep announcing TOPS but never saying to what level.
It's going to be about 1.5 bits here in a few years. So.
FP 1.58.
Yes, exactly.
That is a video in of itself to discuss what the hell that is. So how can you have 0.58 of a bit? It's an average.
Yeah,
it's an averaging.
You pack enough things together and then you divide it just the right way.
Yes, yeah. So in terms of the product portfolio, so today was the launch of Agilex 5D. What Altera did have in the slides is showing exactly what their Agilex 3 and 5 product portfolio looks like from a logic cell and from a TOPS perspective, and I've got them listed here, and I'll just reel them off just so everybody's aware. So Agilex 3, their low end goes from 30,000 to 450,000 logic cells. If we were speaking about another company, that would realistically be that's their mid range. as in the market of FPGAs, Agilex 3 is mid-range.
Yeah, there's still plenty of devices that though they use FPGAs, they're really doing some very small, very specific task where you only need a 10,000 logic elements at that.
Yeah. Well, one of the other companies I know, everything below 100,000 is low end. So to say that your low end is below 500,000, it's a very different way of looking at the market. And that Agilex 3, they've got listed as 2 tops. Doesn't actually sound like a lot, but I guess if it's in something like this,
exactly,
right,
yeah,
that's exactly what it needs to be.
Yeah, a true edge product, just an itty bitty chip that can run on very little power.
I mean, yeah, let me get this out for a second because I assume there's something in the box. It'd be a bit
disappointing if there wasn't. And there you go, one itty bitty chip.
So we have a board, and hopefully you can see that if you're not at 1080p or whatever. But the shiny thing on the left, that's the Agilex 3. It's on its own package, which is then BGA'd to this dev board, which is an 8-layer 10-layer dev board. Yeah, I still got that skill. Being able to.
Yeah, it's a useful skill to have.
Yeah, and on board it obviously has the connectivity pins. It has, are those power regulators? This might be more your field than mine.
Yeah, it looks like some MOSFETs, a couple of switches here, nice USB-C port.
That's good. Thankfully, it's all C. Yeah.
With some WinBond memory here on the back.
Yeah.
And there's a flash chip here.
There's a Micron.
Okay.
It has a list of just do the Linus partners on the back. Samtech, Altera, Trends, Micron, TDK, and Skyworks. Wouldn't Skyworks be a Wi-Fi module or something?
Good question. I'm not sure.
Yeah, so if anybody's wondering, this is the AXC 3000 TI 0131-01, whatever that means. Yeah. More things to get lost in my office, but hey, actually, I wonder how much this costs. Depends if you buy 1 or 1,000, I guess.
We'll have to look it up later.
Yeah. So that's the Agilex 3. This all, the biggest chip in this goes up to 450,000. Then we have Agilex 5E, which we said was more of like the older edge product, going from almost a similar range, 50,000 to 600,000. But in this case, the performance is 16 times higher, 32 tops. And then 5D is the new one. We kind of briefly covered this, the 512,000 all the way up to 1.6 million, 152 tops of Int8, but now with post-quantum
cryptography.
Yeah, post-quantum cryptography. And this is the one that actually has the AI in the fabric, hence why the performance is a lot higher than just simply scaling. Both of those features are going to come down to Agilex 3, they said. If not already, then next evolution. That's the point. We never really spoke about how Altera is going to do generations of Agilex.
Yeah, that's going to be interesting.
Agilex 7 Gen 2.
Well, I'm not even naming. I'm just wondering how they're going to do fabbing and building. They've been tied at the hip with Intel for a while. I would assume whatever's next was already designed for Intel's process nodes. But it's Intel 3 maybe?
I do wonder about that, given how long it's taken Agilex to get out. For the whole portfolio to be launched.
Yeah.
Whether the next generation, whether that's called evolution of Agilex or something else, whether that had already been in design, because of the delay. But again, it speaks to the fact that they now want to go on a very much shorter cadence with chips and such. And then, so after the Agilex 5D, we had the software side, and you were talking about software.
Yeah, so they have a few things going on in software. What was it? Quartos?
Quartus.
Quartus, thank you. Sorry, a bit of an unusual name for a software product.
I believe that's the name they had pre-acquisition for the software.
I would assume
but
so,
it got branded Intel Quartus, and now it's just Quartus again.
Yeah, so they're just released the 2025 third release, so 25.3 for the third quarter of their software.
On the last day of the third quarter.
As long as you make it by the last day, it still counts.
Yes, you don't want to go into Q5.
Yes. That's something that Intel did. This is a new company here, it's Altera. They're not going to do that. We hope.
Yeah. We presume this is the version that strips out all the Intel logos as well.
Yeah. Yeah, you can't see it here since we're hidden with the camera and whatnot, but yeah, there's still a lot of logos around this building, a lot of Intel logos around this building.
We speak so much in this space about mergers and acquisitions. Divestments, not so much. I think this is perhaps the biggest one that I've known about since, or that at least has been involved in the industry.
Yeah. Well, I would probably be up there, but that's a little bit different since
That's
it
like
was never
10%.
fully. Yeah, it was never fully integrated in Intel in the same way.
Rivet Networks, because I knew those guys quite well when they span back out of Qualcomm before being acquired by Intel. Their advantage was that Qualcomm never really fully absorbed them properly.
Yeah.
Whereas I know with Altera, it was a case of we need to be on top of you and make sure that you're doing things the way we need for a collective strategy. So, but it does mean that they're no longer beholden to Intel process nodes if they don't need to be.
Yeah, we'll see. It's something like this. I imagine there's a very long tail to development. So who knows what'll happen? Intel has its own ups and downs in the fab world right now. When Intel 4 was a brief blip. Intel 3, it's not even obvious how long that's going to remain around. They're trying pretty hard to get everything going to 18A. In fact, my understanding is that they expect 18A to bring down costs because they won't have to do quite so much multi-patterning in some situations. Yep. So a lot of ways to go, and they're obviously just getting Agilex out the door right now, so they're not going to talk about what's coming next. But if they want to hit that 12 to 15 month cadence, then what's coming tomorrow is going to be a question that's going to come up not too far in the future.
Yeah, whether that's something like a TSMC 3 or an Intel 18A. I mean, surprisingly enough, they have some options.
They do.
Or even Rapidus. If you want a Japanese 2 nanometer chip. Maybe that. I guess we haven't really spoken about this, but along the lines of one of the FPGA customers that doesn't often get spoken about. It was mentioned here, aerospace, but also defense. Right? They're very much of we want sovereign silicon, made in USA, made in Japan, made in wherever.
Yeah, it's one of the things that has kept Intel in the game over the years has been connection with the U.S. Department of Defense.
Yeah, but just making sure that secure supply chain is there. I'm actually going to go shut the door because it blew open. But yeah, what else is new in Quartus?
So Quartus. So there's a few things going on in Quartus. The big item is their 4th generation system integration tool, which they're calling Visual Designer Studio. We've only seen the slides and the press release, so I haven't had a chance to play with the software myself. Not that I'm qualified to design FPGAs, but
there's new AI tools to help you now.
I mean, that is really kind of the point. Visual Designer Studio, using visual tools to help design out FPGAs. That is where they want to go. Less writing code in Verilog and HDL and more point and click.
Well, I mean, it's the EDA companies, the Synopsys and Cadence, right? They have two different AI tools. They have the assistant that helps you understand what you're seeing, and then the assistant that helps you develop something new. And then at one point it becomes an agentic workflow where the one agent designs something, and then you get the other agent to describe it back to make sure it's actually valid, right? And that sort of thing. FPGA design is very similar, but technically a layer up the stack, right? Because you're now speaking circuits, not transistors, sort of thing. So even though it does, based on where the EDA companies are, Altera might be a little bit behind in terms of integration, you can definitely see the direction where it's all going.
Yeah, if they're behind now, obviously that's not where they want to stay, and they want to get to the same level, if not ahead.
But if you or I can go to one of these tools, without any FPGA design experience and turn around and say, "Oh, design me an audio circuit that tells me if a dog has barked or something," right? That's a very you have a trained model on dog barking, and then something very small for like a sensor, just like fall sensors and glass breaking sensors, that sort of thing. I mean, going to ask it to design a 128-bit ALU is a little bit beyond today, but that's not to say that just simply writing in the phrase "make me a 128-bit ALU" couldn't happen in the future.
Yeah, we're not there quite yet. It's not quite as simple as just saying prompt design me something. But this was in one of the slides. Unfortunately, we can't reference slide deck on the stream, but one of the points was made about reducing design times from days to hours.
Yeah.
Part of that comes from visual tools. Part of that comes from compilation. What was it? 27% faster compiling for the Agilex line since 2023. So in the last 2.5 years, they've brought down compilation times by 27%. Some of their tools have managed to remove something like 6% of the logic modules from designs in certain cases. So they managed to squeeze in both the amount of logic elements required and in terms of clock speeds. I think Fmax was up like 1% in their tools in that same time frame.
Yeah, and that's just simply through software optimization.
Exactly.
It's for those of you who aren't familiar with the FPGA side of what we mean by compilation. When you design your circuits, you have to turn it into a bit stream. And the bit stream gets sent to the FPGA, and the FPGA reconfigures based on the bit stream. That process is called compilation. And when you have 1.6 million gates, or a very complex design to deal with, the benchmark I never enabled at Antec was bit stream generation, because everyone always described it to me as a highly single-threaded process.
Okay.
Because you're essentially trying to access a database and then trying to create a very serial set of binary elements. Well, whatever the bit stream does, just like whatever a compiler does. We all know that compilation can be hideously single-threaded at times.
Oh, absolutely.
So I was never savvy enough to do that, but to say, hey, you can now compile, 27% faster compared to software that was 10 months ago for the same design, but not only compile it, but compile it better, just like in software, compilers get better over time. Yeah. FPGA bitstream compilers get better over time as well.
Yeah, as the compiler gets better, spits out better bit streams. So it's a win-win. Helps, even though it's only a small gain, in terms of the actual logic elements used, anything like that is what helps keep these products around for 10, 15 years if you can squeeze a little more efficiency out of them.
They also had another argument of gen-on-gen improvements. I mean, you brought up the frequency gain earlier. They're saying how going from a Stratix to an Agilex. So when you design your bit stream and you put it on the FPGA, depending on your time enclosure, it ensures how fast you can make that design go. And typically we're talking 100, 200, 300 megahertz.
Yeah, I think the example they used was average Stratix 10 design was something in the range of 350 megahertz.
And with the latest generation, it's now
650.
Yeah. So having double the frequency means that you either use half the resources or double the compute for the same amount of logic gates. But they were saying they can also get that speed increase with fewer logic gates of the same design due to the compiler improvements. I mean, I guess the same is true with standard software. An improvement here, an improvement there, an improvement there, an improvement there. It all ends up being cumulative, if not multiplicative in some cases.
Exactly.
Yeah. If you attack the problem and have 101% gains, sometimes that's better than just having one big 50% gain, right?
Correct.
So, also on the software side, we didn't touch into it, and I think this is one of the things that we need to take away, is that they had on a slide something called the Open FPGA Stack. And I remember talking to another FPGA company, and I tried to bring it in a little bit with the Arrow guy, with Mark, about sole developers and hobbyists especially. They want to play with FPGAs, but the FPGA tooling, unless you're a business, can be terrible, or unless you're willing to pay a license, right? So what can you do on the open source software side such that you can have a community that's building FPGA tools? The problem is every interface to an FPGA might be unique. So if you design a tool for this FPGA, it may not work with any other FPGA.
Yeah, I would assume their bit stream formats are completely and utterly different from each other. So,
which might mean that you might have a different compiler between Agilex 7 and Agilex 5 and Cyclone this and Aria that. So it makes having an open stack without a high-level language, in AI we might call that a TensorFlow or a PyTorch sort of thing, makes it very difficult. But they did have on that slide a commitment to an open FPGA stack.
Yeah, that'll be interesting. They only touched upon it briefly, so I'm not entirely sure what to make of it. But just the concept of an open FPGA stack is very interesting. I'm not going to go say it's going to be transformative.
Yeah.
But again, this is the push to being agile, being able to reach hobbyists, each smaller end users. Every door they can open up to help funnel customers into Altera is another chance for them to convert them to a customer. So.
It's one other thing I want to bring up. It's not software related. It's more what we discussed with Mark with Darren, the dev kits. They have the most amazing name for their accelerator program.
Yes, they do. ASAP.
So how do you improve time to market, which is what everybody's talking about now? How do I get my idea into something that I can sell and generate revenue? Well, you need to get the time to market needs to be as short as possible. So you use as many accelerators as you can. So the Altera Solutions Accelerator Platform Program.
Yes.
So ASAP.
ASAP program.
The ASAP program. But the P is not for program, so it's not like PIN number or ATM machine as some people do. It's partner program, ASAP program. And they were talking about let's decrease that time to market by 50%, 300 partners across 1,400 different FPGAs. Yeah, it turns out they actually have a lot of FPGA SKUs.
They do. And I absolutely get the focus on time to market. And this is another thing that was brought up in the talk. The time to design an ASIC is growing. The time to produce an ASIC is growing. The cost to design an ASIC is growing. Basically, if you want to do anything in fixed hardware, the amount of time you need to get it done is getting longer and longer for some pretty important and unfortunately immutable technical reasons. So now if you want to get something done quickly, a existing piece of hardware that you can just reprogram to what you need, the FPGA, can be a much faster way to get yourself to market.
So, I mean, we've gone through a lot here. This is Altera's first Innovators Day since the split. So the idea here is easing into the new way of thinking, I think, Raghib.
It is. This is very much Altera's reintroduction to the world.
Yeah.
Intel kind of buried them pretty hard, unfortunately.
Well, this is kind of why I wanted to do this. We're not taking payment for this from Altera. This is just something I thought, hey, you're doing this. We need to do something together. We need to get the message out because, as I said right at the start, I think FPGAs are underserved, partly due to how complex they are, but maybe with the tools we've spoken about, maybe with the AI acceleration, maybe with the assistance, we reduce that barrier to entry. The question is, do we lose FPGA engineers if that happens?
It's a possibility. But
the thing is, with anybody, mildly on the spectrum or what have you, we'll always want to dig deeper. We always want to take apart the microwave to see how it works.
I will have you know I've never taken apart a microwave.
Not yet.
That is true. I've still got plenty of time.
Still got plenty of microwaves.
I'd have to go buy a new one.
It's I wanted to just at least experience what the new Altera would be like. I'm spending a lot of my time in the industry just wanting to be part of experiences because stuff like this doesn't happen that often.
No, I mean, there are really, three major players in the FPGA space these days?
The high volume, mid to high players you got Xilinx and Altera obviously there. Lattice plays a bit more in the mid-range low end, but they actually sell the most chips out of anyone. And then you have a bunch of tier 2 players. I was telling you earlier, I saw one of the tier 2 vendors FPGAs in one of Intel's packaging facilities last year in Malaysia. So there are so many places where FPGAs play that people don't realize, and that's why I think they need to, like I said with Mark Monroe, shout from the rooftops that dev kits exist, that it's easier than ever to get into this space, and FPGA engineers are some of the most respected in the companies that we visit. Yeah,
I can absolutely believe it.
It's I did an interview with Yasmina over at Tens Torrent, and the first thing I introduced was her background. It's like FPGAs, and all the comments were like, "Yes, FPGA engineer, amazing." They clearly know what they're talking about. So we're gonna wrap up the stream here. There's been a couple of questions in, but I don't think we have the capability to answer them. A blackboard is not a whiteboard in dark mode. I will say that. So we're going to go, I believe, get some lunch and then get some of the, go into the demo room, and hopefully we'll be able to take pictures as well. I'm really excited for that.
Yeah, that's a really nice demo room. Didn't you say it used to be a Tesla workshop?
Yeah, they used to drive the cars in so they could do stuff with the FPGAs inside the self-driving stuff. So
that'll be fun to look at.
Yeah, cool. So thank you all for joining this stream and staying for the keynote and through our discussion topics. If you want to see more of these, do let us know down in the comments and in the chat. I'd like to thank Ryan for joining me.
Well, pleasure to be here
again.
Always good to see you as well.
And we'll catch you on the next one. There's more videos coming this week.